everyone. How are you all doing? Good morning, Sadex. How are you? Oof, you guys are already chit-chatting. Okay, how are you all doing? How is your preparation going on? If I'm audible and visible to you properly, let me know in the comment section. Jai Hind, Sharma ji. Good morning. I'm great, Sadex. How are you? We are great. How is your preparation going for the boards? It's 4th Feb. You have less than how many days left? Only 13 something, right? Mast, right? Great. It's fine, Sharma ji. We have started our final revision now, and there is nothing to be scared. Okay, I am here with you. We will study everything from the start in this live, and in the next live for other 2 chapters we'll do all the questions as well, MCQs, all the numericals or the conceptual, everything will go in detail. Okay, am I not audible, everyone? Let me know. Hi Abhinav Yadav, how are you? Hi Anmol, how are you? I see a lot of Anmol Yadav, Abhinav Yadav. How are you guys? Yes, exactly. Rani is saying, don't be scared, only try to do best. That is the best advice. Hi, Death's God. How are you? Hi, Sona. Hello, welcome to the live. Final. Oh my God. Yes, final. You have so many subjects. So, we are starting from today. Till 10 or 11 you will study all other subjects, and from 11 you will start studying maths. I know you, right? So, till that this is our final revision, and we'll do the final stretch will be just 2-3 days before the examination, but now we'll do everything from the start. Okay? Hello ma'am, old student with new ID. Okay, what was your name? Let me know if I remember or not. Arey, so what happened? Everyone can give gyan. Lots of people have different kind of gyan. Okay, now send me a thumbs up, everyone. Give me a thumbs up and like the session if you are here. Give me a thumbs up if we can start this live. If we can start this live, if we can start our final revision. Yeah, send me a thumbs up, everyone. I need a thumbs up from everyone. Yeah, of course, in the exam gap days we'll all be here. Physics, chemistry, biology, everyone will come here. We'll study again from the start till the examination date. Okay, we'll do everything, all the numericals, all the expected ones, everything. Okay, great. Firestorm, Sadex, longitude, everyone gave a thumbs up. So let us start. Ma'am, they have been asking very tough questions from magnetic effect of electric current. Who has been asking? CBSE, did you see previous years? Okay, it's fine. We'll cover all the questions today, all the previous years, all the expected ones, all the tricky ones. Okay, let's study everything. Don't panic. Don't be scared. Okay, let us start with the very first. We have electricity. Okay, electricity is kind of a chapter that is majorly focused on numericals, right? Numericals, and we have lots of topics in numericals as well to cover, right? The major part of this chapter comes from numericals. So some ground rules for this live. First, each of you has to answer. Okay, each of you has to answer, but first we'll start with revision, right? First we'll start with revision, and with that topic, each topic will do the numericals and questions, right? So each of you, I expect each of you to answer each question, right? Hi Siddharth Patak. Okay, let's start with the very first. The first topic we have in electricity, very basic. Let's go through it quickly. What is that? That is charge. Charge is a property of the matter. right? That is it. Charge is a property of a matter that helps us to decide what kind of current will be flowing, what is happening inside that wire, right? So it is the property of a matter that causes electric effects. Okay, no, not MCQs. We'll do numericals, we'll do conceptual questions, all of that, Sharmaji. Not just MCQs. I think I have just 1-2 MCQs, but I have. Okay, so charge, like charges repel each other, unlike charges attract each other. That is it. SI unit is coulomb, right? SI unit of charge is coulomb. Till I tell you what current is, let me know what is the SI unit of current. I'll erase it. What is the SI unit of current? Let me know in the live session, live chat. Quantization, we'll study about quantization. I'll tell you about quantization as well, don't worry. Okay, next we have current. Current is, we studied about charges. Now we have negative charge, positive charge. One very important property of a charge, as Sharma ji said, is quantization. What is quantization? Quantization means that if I say that in a conductor 1.5 electron is flowing, 1.5 electron is flowing, can that happen? Can that happen? No, ma'am, that can't happen, because electron is a particle, right? It is a particle, just like us. Just like, let's say I am a particle. You cannot say 1.5 ma'am is teaching us physics, right? That is not possible. So just like that, electron is a particle, and half of it cannot be possible to exist, is not possible to exist. Okay, that is quantization. Now the rate of flow of positive charges. We studied about electrons, we studied about protons. Protons are positive charges. So the rate of flow of positive charges, very important. The rate of flow of positive charges is called current. Okay. Now, if the rate of flow of positive charges is current, so electrons, negative charges, will be flowing in the opposite direction of the current, right? And we know it is measured by a device called ammeter, and yes, the SI unit is ampere. Very good, Sharma ji, Sadhana, very good. Hi ma'am, do you remember me? I told I scored 15.5 out of 10, now I scored 22 points. That is great. Shrivashan, yes, I remember you told me that you scored 14. That's great. I really appreciate. I'm so proud of you as well. Okay, Sharma ji, resistance is 10 ohm. Jer is saying 10 coulomb. Okay, let us solve this numerical. An electric current of 2 ampere. What is given? See, what we do, what I always tell you, as we read the numerical, we write what it is given in the question. Okay, so 2 ampere of current is given, so I equals to 2 ampere, right? Through a wire for 5 minutes, so T equals to 5 minutes. Now to solve this numerical, what is the main formula of this chapter? The most basic formula of this chapter is Q equals to IT, the relationship between charge, current and time. We have answers as 10 coulomb, 600 coulomb and 600 coulomb. Okay, let's see who is correct. Find the total charge that passes through the wire. We have to calculate the total charge. Now one thing you need to remember in this formula, Q equals to IT. Q is always in coulomb, current is always in ampere, and time should always be in seconds, right? Time should always be in seconds. So if it is given that time is 5 minutes, you have to convert that into seconds. Okay. Hi Beauty Yadav. Ma'am, should we calculate with respect to seconds, Jer? You have to always convert time into seconds. Okay. Except one subject, one topic, which is our electrical energy, where we use kilowatt hour. We'll see about that. Okay. Yes, very good. 300 seconds, great. So we have, simply we'll use this formula, Q equals to IT. To convert 5 minutes into seconds, we'll multiply it by 60, right? That will be 300 seconds, correct? Now Q equals to IT. Q is, we have to find, 2 is given and T is 300. That will be 600 coulomb. right? Everyone was correct. Great, great, great. Yes, next, just wait for 1 or 2 slides. I've got you all the questions, all the most expected, most repeated questions as well. Yes, yes, yes. I will just wait for 2-3 more slides. Okay? Okay. Next, we have again a very important concept, that is potential difference. Now, what is the unit of potential difference? Let me know. What is the unit of potential difference? Now, what is potential difference? I have 2 points and I have a test charge. Test charge is a positive charge. A test unit charge. Unit charge means 1 coulomb. Okay, unit charge means 1 coulomb. Now I have a unit charge at point A, right? I have to bring it to point B. So I'll do some work, right? I'll work to bring that charge from A to the point B, right? So the work done to bring a charge of 1 coulomb from one point to the another is called potential difference. Very good. Great, everyone. Sharma ji, Firestorm, Boltmaster, Deadpool. Oh, you guys have some great names. Everyone is saying volt. That is true. The SI unit of potential difference is volt. Again, a very important formula. That is, this potential difference is equal to work done per unit charge. Potential difference is equal to work done per unit charge. Great. Okay, very good. Now next we have, yes, joule per coulomb. Okay, Jair, who said joule per coulomb? Jair is saying joule per coulomb. That is also true because work done is measured in joule and charge is measured in coulomb. So we can write the unit. If somewhere it is written that joule per coulomb, that means that is volt. That means that is potential difference. Okay, class will go a little long, Arav, because we are going to do 2 chapters and we are going to do all the questions, all the numericals. Okay. Yes. Hi, Yuvan. I do remember you. Okay. Hi, Hanji Bhumi. Okay. Yeah. So there is a very main important point that you need to remember. See, this is a battery. Now, what will be the direction of electrons? It will be this, right? And current will be in opposite direction of electrons, right? This is my negative, is my low potential. Positive is my high potential. Till here, any doubt? Okay. Now, electron goes from low potential to high potential, and current goes from high potential to low potential. You have to just remember this. Okay. Current flows from higher potential to lower potential. Electron flows from lower potential to higher potential. Okay. Yeah, it doesn't. Arav is asking stress. It's fine, Arav. You are meant to feel stressed. These boards are designed in such a way that you feel a little bit stressed, but that's fine. That's okay. They are just preparing you for future studies and everything. Okay? Don't worry. Don't take too much load. Don't take too much pressure. We are all here. I'll do all the questions for you. Yes, Arav, Sharma ji, we are doing all the questions. Okay. Okay, next is Ohm's law. Again, a very important concept in the chapter electricity, right? The Ohm's law, it says we have a conductor. Right? Now, the potential difference, we just studied potential difference. They are saying potential difference was V, right? Potential difference across 2 ends of a conductor is directly proportional to current flowing in that conductor. It's directly proportional to current flowing in that conductor, provided. If you ended your definition till here, that will be wrong. Okay, you have to write provided that its temperature remains the same. Now, if we cut out the proportionality constant, we'll get a constant, that is resistance into I. So, V equals to IR is the most important formula of this chapter, given by our very own Ohm Baba, that is Ohm Baba's law. Done? Anyone has any doubt? Till here, anyone has any doubt? You can go check in the down there. There's a link. You can go and join the WhatsApp channel. There you will get all the information about all the classes we are having. Okay. Yes, that is our next question, Sharma ji. Just let me explain. Now, this Ohm's law has a graph, that is VI graph. We call it VI graph. Okay. Usually in normal case, V will be on y-axis, I will be on x-axis, and the slope is given by y-axis by x-axis, that you know in the math, right? On y-axis we have V, right? And on x-axis we have I, right? So this is also one more important formula. Go check, go revise this. Okay. Proportional constant there, it means that something depends. If we say that my potential difference depends on current, so it can depend in two ways, right? It can either increase with increase in current, or it can either decrease with increase in current, right? So that is how we say proportional. Proportional means it depends in somewhat manner, it is proportional to the other constant or other object. Now if it is increasing with increasing, then it is directly proportional, right? Directly proportional. Proportional simply means that it increases or decreases with its portions. As one thing's portions are increasing, the other portions are either increasing or decreasing, right? And if it is decreasing, it is inversely proportional. Done? Okay, let's move on to the next. We have, I am guessing, a very important question. Very basic but CBSE 2023 question. Okay, so let me know the answer of this question. Okay. Yes, boards, 99% of the students will get passed in boards, Arav. Okay, so don't worry. Ohm's law will be question mark asked in examination. Yeah, Ohm's law, the definition of Ohm's law can directly be asked in your exams. The circuit diagram of to verify Ohm's law, that can also be asked in your exams. Okay. Okay. Thank you, Ritik. B. We have the answer as B. Okay. Let's read it. For verifying Ohm's law, we design an electric circuit diagram in which we show the arrangement of different circuit components. We find with respect to resistor, ammeter is connected in parallel, voltmeter is connected in series. Ammeter is connected in series, voltmeter in parallel. Ammeter and voltmeter both connected in series. Ammeter and voltmeter both are connected in parallel. Everyone is saying that it is B answer. Okay, yes, everyone is correct. We know the circuit looks something like this, right? We have a resistance and we have a voltage source, right? I'm just making a normal circuit. Okay, now with respect to this resistor, my ammeter will be in series and my voltmeter will be in parallel. Okay, done? That depends on kid to kid, Arav. Okay, ma'am, but my doubt is regarding proportionality constant. Okay. Proportionality constant. See, proportional. See, if I say that V increases with as I increases, but I don't know how, right? Let's say V equals to 1 into I, okay, but V equals to 2 into I, and then V equals to 4 into I. So these constants, that means still in this these three cases, V is directly proportional to I, but in this case V is equal to I. In this case V is 2 times of I, and in this case V is 4 times of I. Now if it increases and it becomes 10 into I and it becomes 40 into I, this is still proportional, right? Directly proportional, they are increasing, but now the constant is different. The constant is different. So constant tells us how much the proportionality is there. Okay, Ritik, what do you not understand? Little bit fast. Okay, we can go slow. Any doubt in this question? Let me know if you have any doubt in this question. I'm coming here on your mobiles. What else do you want? Let me know what do you not understand in this question. You can say, Sharma ji, they are designed in such a way that you are preparing for something big. But so if you prepare for something hard, you will be able to do something easy, right? So they are prepared in such a way. Okay? Okay. Next question we have a resistance, and then we have question. Okay. Next question, next topics we have resistance and resistivity. Let me know their SI units, both resistance and resistivity, their SI units. Now, resistance is just a property of a matter of a conductor that opposes the flow of charges through it. In a conductor, charges are flowing, right? Resistance tries to stop it. Just like friction tries to stop our car, stop us, resistance tries to stop the flow of charges. Okay, done. Next we have resistivity. We'll do it very quickly, all the concepts, and we'll jump to questions right away. Okay, now resistivity is kind of the same, but it is the property of conductor that determines how strongly will it oppose the flow of charges. It is a property that opposes the flow of charges. It is a property that tells us how strongly it opposes the flow of charges. Copper will oppose the flow of charge with a certain strength, but aluminium on the other hand will oppose the charge with certain other strength. Correct? That is depending on resistivity. Okay? Yes, that pull is saying ohm and ohm meter. 78% you have in pre-boards. Okay, you can easily get 85 if you start working hard right now. If you start solving the questions, you can easily reach to 85 between 90. Okay, now some properties. Yes, the SI unit of resistance is ohm, and the SI unit of resistivity, my friend, is ohm meter. Done. Any doubt in all this? Now, a very important, very easy formula we know, R equals to rho L divided by A, right? Where rho is resistivity, right? This is resistivity. L is length of the conductor and A is area of cross section, right? Area of cross section. From here we have the formula, we have the unit as ohm, right? If I rearrange this and find a resistivity, that will be rho into A divided by L, and its SI unit will be ohm meter. What is happening? Done. Any doubt? Derive the SI unit of resistivity. Okay, see, you have this formula, okay, R equals to rho L by A. This can actually, they can ask you in the examination to derive the units of resistivity. Definitely. If you get AIR 1 to AIR 5, I'll definitely get you a gift. Okay, so what you have to do? First you have to find the formula of rho. Rho will be resistance into A divided by L, right? Now resistance unit is what? Ohm, right? Area will be meter square, right? And length is meter, correct? Meter and 1 meter cancels out. This is rho. So rho will be ohm meter. Done? Everyone, any doubt? Okay, Sharmaji. Okay. Let me go to that question, okay? Okay. The question we have, if length of wire is increased by 10% by stretching. Now, very important keyword we have, stretching. Calculate the percentage change in its resistivity and resistance. Let me know if you guys can solve this question. Can you give me the percentage change between the wire when it was not stretched, but after stretching the wire was stretched by 10%? What will be the change in resistance and resistivity? Oh, Devdas is back. Hey, why will I forget you, Sharma ji? You are one of the great students in my class. Okay, no change in resistivity, Sharma ji is saying. Okay, let us first understand the question. Okay, we are given a wire, right? We are given a wire, let's say of length L. Now they are saying that we stretched the wire and increased its length by 10%. So till here the length will be still L, right? And this is the 10% more length, 10% increased length, right? So let us calculate how we find the increased length. That is very important. Resistivity is the property of matter. Is the property of material that did not change with other quantities provided temperature remains the same. Very good, Jay. Very good. Okay, resistance also increased by 10%. Tech AI is saying 0% resistivity, 20% resistance. Okay, we have different questions. Okay. Yes, exactly. Area will also decrease. Okay, let's see how we calculate this. First, how do you solve this question? You have to first start that first before stretching. How do you write this question? In this session, okay, listen everyone, this is final revision. Now we are not here just to solve the question. We are also here to learn how to present your solution. That is very, very important. Okay? Done. Now understand this. Before stretching, that is how you will write. Okay, before stretching, let's name it 1. So before stretching, L1 is L and area is also there, right? So area is A, right? So resistance will be what? R1 will be rho L1 divided by A1, right? And let's say rho 1, correct? Now after stretching, this is how you all will write. You look at this very carefully. Okay, after stretching, what will happen? Now L2 will be what? Can you clearly see? L2 will be L1 L plus 10% of the original length, right? L2 will be L1 plus 10% of the original length, right? So we can write L1 plus 10 divided by 100 L1, right? So this will be 100 L1 if you take the LCM, and this will be 100 L1, right? Plus this will be 10 L1. So this will be 110 L1 divided by 100. Understood? Now this will be 1.10 L1. Understood? Everyone? Anyone has any doubt in this whole calculation? L1 plus 10% of L1, right? So if we take the LCM, this will be 100 L1 plus this will be 10 L1. That will be 110 L1 divided by 100, right? And if I take this 100 and put it as decimal, that will be 1.10 L1. Understood? So L2 becomes 1.1 L1. Now by the constant or by the proportionality constant with which length increases, that will be the same amount with which area decreases, right? That will be the same amount. This is our institution Arav. We have classes for 11th and 12th. You can connect with us and you can join that as well. Okay, so L2 is 1.1 L1. Now by the amount with which length increases, with the same amount area will decrease, right? So A2 will be A1 divided by 1.1, right? And L2 was 1.1 into L1, correct? So can I find R2 now? R2 will be rho 2 L2 divided by A2, right? Rho 2, now rho. See, the same wire is being stretched, so resistivity won't change, because resistivity depends on, this is a PYQ Sharmaji, but I guess the constants, the values are a bit different, okay? In PYQ, this is a PYQ, but in the value it was 20%, I guess. Okay, so resistance will be same. Rho 1 is equal to rho 2 is equal to rho. So the answer is 0% change in resistivity. We all know that. So rho L2 is 1.1 L1, right? And A2 is 1.1. A2 will be A1 divided by 1.1. Can you solve it now easily? This will be rho. Let's just write L1 here and A1 here. Now this is in divide. It will go multiply, correct? So this will be 1.1 into 1.1. This is R2, right? So R2 will be 1.1 into 1.1. What is the square of 11? What is the square of 11? How did you know, Sarmaji, that in my room there was a ghost? Acha, that. Oh, they came to give me chai. Okay, so R2 will be 1.1 into 1.1. That will be 121 and it will be 1.21 into. Now this whole rho L1 into A1 was what? Rho L1 into A1 was, now rho 1 equals to rho, right? So this is rho L1 by A1. So rho L1 by A1 is R1. So can I write 1.21 into R1? Is this till here any doubt? 1 to 1. Yes, very good, Sharmaji. Okay, now what we have to do, do not skip your question after this. Do not leave your question till here. We have to calculate the percentage change in resistance, right? Learn how to write the questions as well. Okay, everyone? So this will be final resistance minus initial resistance divided by initial resistance into 100, right? So RF is final was 2 minus R1 divided by R1 into 100, right? R2 is what? 1.21 into 1.21 R1, right? R2 was 1.21 into R1, right? 1.2 R1 minus R1 divided by R1 into 100, right? So this will be 1.21. If I take R1 common from each of this, it will be R1 here, and in divide we also have R1. 1.21 minus 1 into 100. Okay, and this cancels out. 1.21 minus 1, that will be 0.21. That will be 0.21 into 100. So the change will be what? 0.21 into 100? 21. this gives us 21. So by 21% the resistance will change. Anyone has any doubt in this? I am not from Karnataka, but I am in Karnataka right now. Anyone has any doubt till here? Okay, there is a great advice that Ayush gave. Ma'am, can you teach the increase in length while simultaneously the decrease in area? I understood the logic that stretching time it will decrease area, but why 1.1? Okay, Jair, let me see. Okay, so we have volume, that is area into length, right? And this is the volume before stretching and this is the volume after stretching, A2 into L2. Now this much you understand that volume will remain same, right? The same length, if the area increases but length is decreasing, volume will remain same, correct? Okay, tell me if you are understanding. Let me know, Jair, if you are understanding. So till here volume will be same. Now in here let's say length L1 is L and L2 is decreased by 2. Okay, let me just get a concept that L2 is decreased by 2, right? So in here V1 will be what? A1 into L by 2. No. A little bit of mistake. This will be A1 into L1, right? Now V2 will be what? Let's say area is simply A2 and L2 is L1 by 2, correct? L1 by 2. Now if you see, the volume is same. Volume is same. So can I equate these two? V1 equals to V2, right? So this is A1 into L1 equals to A2 into L1 by 2. L1 by 2, right? So this L1 cancels and A2 will be what? 2 times A1. Did you understand now? Length is decreased by 2, area is increased by 2, because whatever the constant we have here will get multiplied with area. Understood, Jair? Let me get my chai. I need some power. Okay, anyone, any doubt in this question? Jair, Sarma ji, Ayush, Sadex, Rani Gupta, anyone has any doubt till here? Okay? Okay, Jair, great. Yes, Bhumi, what is your doubt? Okay, let us move on to the next slide. Next we have again one more question. This question is a little bit lengthy, but read it carefully. Okay, the question is, you have 4 resistance wires. 4 wires. First read it very carefully. We have 4 wires of same material, so their resistivity is same, equals to rho 3 equals to rho 4 equals to rho, right? If they are of same material, all their resistivities are same. Select the wire which will offer the least resistance, which will offer the whatever you need to find, write it down, because in the exam it can happen that instead of writing least resistance, you give the answer as most resistance, right? You do not do that. So offer the least resistance to the flow of current in an electric circuit. We have 4 options. Let me write 4 different cases for you. 2L, 2D, L and D, L by 2, D by 2, L by 4, D by 4. Let me know which one of these will offer you the least resistance. Ma'am, Kalesh, yeah, of course. Yes, Sharma ji, you have to, because I'll explain it. You do it one by one, or if you don't want to do it one by one, you tell me the answer. What do you think should be the answer? Hey Manya, Ayush is calling you. He's sad. You guys should be preparing. You don't have mostly 10 days for your exams, and this is what you're doing. Yes, Bhumi, ask your doubt. Pradyuman is saying A. A option, Pradyuman. Okay, let us see, right? Okay, Gunika Rani is saying C, Gunika is saying A, okay. Now, okay, Devdas, good luck with that. Okay, Rani is saying A, Sharma ji is saying B. Okay, okay, okay. Let us see, let us see. Now, first tell me, we know that resistance is equal to rho L by A. Now, technically, if I have an MCQs, what will I do? I'll see that I want the least resistance, so I'll choose the option with least length or greater area, right? But now look at the options. In here, you have least length is in L by 4. But area is also least, but diameter is also least. So if diameter is least, area will be least, right? Correct? So that is why you have to solve all the options, right? Least resistance. But let's see how you can solve it very quickly. We have 2L, 2D. We have, let us convert this whole page into 4 parts, so that you can understand it very quickly, okay? Arey. And then we have the 4th part. Okay, let us solve it now. In the first part, we have L1 as 2L, 2L and D as 2D. Remember, it is diameter, okay? This is 2L, diameter as 2D. So what you have to do? First, you will find its resistance, radius. So radius will be D1 by 2, that will be 2D divided by 2, right? And that will be D, correct? Now, we need R equals to rho L by A. And for this case, everything will be 1, 1 except resistivity, right? So, D1 is D. So, area will be, A1 will be pi R square. That will be pi D square. Done. So, this will be rho. L1 is simply 2L, right? And area is pi D square. So, R1 comes out to be 2 into rho into L by pi D square. Done. R1 is calculated, right? Area is inversely proportional to resistance. Yes, very good. Which question did you ask, Rani? Can you ask again? I think it went up in the chat. I'll explain it, just ask away the question. Now in B part we have length as L and diameter as D. So length is L2, length is L, D2, diameter is D. So what will be R2? R2 will be D by 2, right? So what will be A2? A2 will be pi R2 square. A2 will be pi R2 square, right? And then this will be pi D square divided by 4. R2 square is D square divided by 2 whole square, D square by 4. Okay? Okay. Okay. Now we have R2. R2 is rho L2 divided by A2, right? Now rho is here, L2 is simply L. A2 is pi D square divided by 4. Now this 4 will go up here. So R2 will be 4 into rho L by pi D square. Understood? Understood? Is question ke pehle wala. Okay, let me complete this question. I'll come back to that question again. Okay? Yeah, not coffee. I'm a chai person. Okay? Okay. L3. Now in the option third, L3 is L2 and diameter is D2. L3 is L by 2, diameter is D by 2. Understood? And then radius will be what? R3 will be D by 2 and then 2. So that will be 4, right? And then area will be what? A3. A3 will be pi R3 square. So pi D square divided by 4 square is 16. So this will be R3 equals to rho L3 divided by A3, and R3 will be rho into L3 is L by 2 divided by A3 is pi D square divided by 16. Done. A3 will be pi D square divided by 16. Done. Then R3 will be rho L by 2, this 16 goes up and this is pi D square. So this 2 get cancels and this R3 will be 8 into pi, 8 into rho L by pi D square. Done. Any doubt in this? Any doubt? Let me filter your comments. Okay. And then fourth we have L4 and D4. L4 we had L by 4, right? L by 4, D4 as D by 4, where R4 will be D by 8, right? And A4 will be D square divided by 8 square is 64. Right? Pi R square. R is D by 8. D square divided by 8 square is 64. So R4 will be rho L4 divided by A4. Now rho L4 is L by 4. A4 is pi D square divided by 64. So that will be rho L by pi D square 64 divided by 4. That is my R4. So R4 will be, this cancels out and this gives 16. 16 rho L by pi D square. Now which of these resistances is the least? Now ma'am, we can clearly see that out of these two, R1 is the least. So R1 is the answer to this particular question. For R1 we had L1 as 2L and D1 as 2D. That is my very first question. A part is the answer. Done. Anyone has any doubt? A is 2R, B is 4R, C is 8R, D is 16R. Very good, Jair. Great. Okay. A is the least resistance. Very good everyone. Whoever answered it as A, very good. Roshan is saying no ma'am. What no ma'am? No doubt. What this question asked in more than CBSE question marker? I am from ICSE board ma'am, and what this question asked in more than CBSE question marker? Huh? What are you saying, Rani? No. Let me tell you, Sharma ji, wait. Okay. Hello, Keshav Gupta. Okay. Now we have seen, now what more you can do? See, this is a tricky thing, but you can see how to solve it. Now, see, length is decreasing by just a factor of 2. L1 is L, L2 is L, what was it? L2 is L by 2. Okay, this was 2L, this was L, L3 was L by 2 and L4 was L by 4. Okay, so in this each case, resistance is just decreasing by those points, right? Here it decreased by 2, then decreased by again a factor of half, again a factor of 4, right? But if you think about area, we are given with diameter. Diameter is again 2D, then D2 is D, D3 is D by 2 and D4 is D by 4. right? Correct. Now you can easily solve this. How? Out of this you have to find area. Now area, just follow it like this, do it like this, not the way we did here. This is a question for, they didn't tell you that it's a 2 marker or 3 marker. They can give you in 4 marker, 5 marker as well, right? But if they gave you in MCQs, this is how you do this. Okay, you wrote this everything. Now radius is, we know this will be simply d, r2 will be d by 2, r3 will be d by 4, and r4 will be d by 16. Now as you see, area will be d square r square, right? So area will be what? Area will be d square pi d square. A1, A2 will be pi d square divided by 4. A3 will be pi d square divided by 16, and A4 will be pi d square divided by 64. Right? Wait a minute. Here we had 8. Okay. This is 8. D by 8. Right? So this will be areas. Now you just find which is the least area. See, which is the least area. Least area is this one. Now this area will give the biggest resistance or largest resistance, and the area with least area, it will give the more resistance. Right? This is the least area, it gives the largest resistance. This is a large area, this is a large value of area, and it will give the least resistance. Now why area is the deciding part here? Because see, if L is decreasing by 4, area is decreasing by 64. Area is decreasing the most, so resistance will be increased the most. Okay. Yes, I'll explain the question before this. Okay, done. This is also how you can solve this. The other part, this is also there. This is also there for 3 marker questions. But you can also solve it like this by using a little bit of brain. Okay? Yes, this is the hack. Okay, Sharma ji? Yes, a question before this. What did you not understand in this, Rani ji? (2026) mein hard question. Yeah, you can say that. But if you know how to solve these questions, if you know the basics, okay? Yes, you should use the concept stretch only when it is asked. Yes. In some cases, they will tell you, if they are not using stretch, see, the questions will be very clear. They'll tell you that the length is increased, but area is not. They'll simply tell you the length is increased. But if it is written stretched, so you have to decrease the area as well. Okay? Yes, exactly. The case in which area is the biggest, area is the largest, resistance will be the least. Very good, Sharma ji. Okay, thank you. Okay, 2024-25 easy tha. Okay, that is great. If you find that easy, that is a really good sign. Okay, Rani, I was asking, what did you not understood in this? We have L, they are saying we stretched the length. If we stretch the length will increase, but area will decrease as well. So we converted it into 2 parts. First, before stretching, L1 is, length is simply L, area is A. So resistance will be rho 1 L1 by A1, that is rho L1 by A1. After stretching, the length, in that length, 10% length increased. That means in the previous length, 10% of the length got added. Okay? So L1 plus 10% of L1, and this is how we solved. We got the answer 1.1 L1. Since it is stretched, area will be decreased by the same amount. So A2 will be A1 by 1.1. Now we did resistance, rho 2 L2 by A2. We put all the values of lengths, and this is how we got the answer. Okay? competency based questions. Competency see, competency based questions will simply be your numerical what do you say, MCQs and conceptual questions mostly. Competency based questions mostly will be conceptual. Okay, ma'am, where is the best guide I can practice all the questions without missing any topic? You can check the Oersted books, they are good. Question hard rahega, which one? See, that we cannot predict because this is the first time CBSE has asked us, has told that the question will be a little bit hard. So we are just preparing all the concepts and the previous year questions, because even if the paper will be hard, it will be from high weightage topics. The topics, why we say high weightage topics? Because those topics are the ones you will use in your future, in your 11th, in your 12th, PU1, PU2, okay? So that is why we call them as high weightage topics. That's why CBSE focuses on those topics so much, okay? So these questions, these stretching questions can be good, and yes, I'll explain one more time. Let me just, yeah, Oersted is enough, Yuan. Don't go to other books, don't go to so many materials. In my videos as well, if you saw the strategy ones, I have already told you, go with NCERT exemplar, then go with PYQs. You are studying all these NCERT exemplar PYQs from Oersted, then stick to one book, okay? Okay, Sharma ji, I'll give you hack for each of the questions. Do you like this hack or not? Okay, yes, I am American as well, Rohan. I am from America. Okay, chalo. So what did we see before stretching? L1 is simply L. After stretching, 10% of the length increases, so we add L to 10% of length in the previous length. We got the new length, then we decreased the same amount of area because it is stretching. We calculated R2, right? Then percentage change, this formula is very important. R2 minus R1 divided by R1 into 100. You put all the values and you will get that the length, that the resistance is increased by 21%. Okay? Okay, let's see the next question we have. The next question or the next topic, what do we have? Oh, who was asking? Sharma ji, we have your question on the graph. Okay, let me tell, I'll explain you first the graph. Okay, this is very important topic. Maximum chances of coming question from Ohm's law is graph, because it is a bit tricky. Okay, okay, look at this first. You have two kinds of graph. You can have two kinds of graph. This one graph, right? This is V and this is I. And this other graph, in this you have I here and V here. What I want you to tell me is what is the slope in these two cases. What is the slope in these two cases in form of V and I and in form of R as well. Let me know what is the slope in these two cases. Sorry about that. Let me know. Sharma ji is saying first V equals to IR. Sharma ji, I've asked you slope. Yes, Yuan is saying R and 1 by R. But Yuan, Sharma ji, I want you to tell me in case of V and I as well. Will it be V by I or I by V? This is the first case. This is the second case. Now tell me. Okay, we have a doubt question. Resistance of a metal wire of length 2 meter is 30 ohm at temperature 25 degrees. If the diameter of the wire is 0.6 mm, then what will be the resistivity of the metal at the temperature? Arey, Prakash ji, this is very easy. We have the formula R equals to rho L by A, right? Now we are given that length is 2 meter. Length is 2 meter given, right? Resistance is also given, that is 30 ohm and 30 ohm. And we are given with temperature. Don't look at temperature at all. Okay, these questions are designed to confuse you. The diameter is 0.6 mm, 0.6 mm. So you just convert it into meters first. That will be 0.6 into 10 raised to power minus 3 meter. And we have the formula rho L by A. You just find A from the resistance, and resistance is given, length is given, area is given, rho can be found, right? Okay, VI, let me see, VI slope is more, resistance is more, and IV में जो slope is less, resistance is less. V by I and I by V. Okay, very good. Let's see if you guys are correct or not. See, slope, we have studied in maths that slope is y-axis divided by x-axis. This is how you have to remember, everyone. Slope is y-axis divided by x-axis. On y-axis we have V by, and on x-axis we have I. So in first case, S1 will be V divided by I. Understood? In the second case, on the other hand, see, the formula of slope is y-axis by x-axis. But in here, on y-axis, we have I, right? And on x-axis, we have V. On x-axis, we have V. So, S2 is I divided by V, right? Now, the second step, you have to see Ohm's law. Ohm's law says what? It says V equals to I into R, right? So, from here, R will be what? V into I, correct? R is V into I. Now, here I have V into I. So, can I directly write that S1 equals to R? S1 is equal to R. Can I directly write this, right? Then on the other hand, in this part, S2, now R is V by I, R is V by I. If I inverse this, 1 by R will be what? I by V. If I reciprocate this, 1 by R will be I by V, right? So this is I by V. So S2 I can write 1 by R. S2 I can write 1 by R. Till here, anyone has any doubt? Because this is the main concept of the questions of graph, okay? This is the main concept of the questions of graph, and now we'll solve the graph questions. Okay, done. Now coming back to the question of the graph. Now let me know what is the answer to this question. Class will go on till a little bit late, Simmi, okay? Because we are doing all the questions of all the topics of the two chapters, electricity and magnetic effects of electric current. IV slope में slope बढ़ा तो resistance छोटा. Okay, great. Yes, very good, Sharma ji. That is true. Ma'am, I had maths class, that's why I couldn't join from the beginning. How many questions did you do? No, you won. We didn't do much questions. We just started with it. See, we are doing only we are on Ohm's law and resistance topic, right? So we'll do, after this we'll go to power, electric energy, heating effect of electric current, combination of resistors, everything, okay? Okay, now let me know the answer to this question. Sharma ji is saying 1, current is directly proportional to voltage. Yes. That is good. First, we have simply the definition of Ohm's law. How electric current is related to potential difference. Electric current, potential difference, we know V is directly proportional to I, or you can write V equals to I into R. That is Ohm's law. Right? And then we have another question. We have two VI graphs A and B. Okay, this is A, this is B. For series and parallel combination of two resistors are as shown. State which graph shows A series and B parallel combination of the resistors. Although we didn't reach to parallel and combination and series combination, but we'll see. Okay? Class will go till late, Simmi. हाँ, okay, Roshan ji. Okay, let us see what is the, yes, we have answers from Sharma ji. A is series, B is parallel. Okay. Hi Abhinav Yadav, hi vlogs. Okay, done. Let's see. Now this graph is, let's see what is the slope of this graph. So whenever a graph question is given, the first thing, step 1 is to find the slope. Step 1 is to find the slope. So what is the slope? Y-axis divided by x-axis. Y is V, X is I. So that will be V divided by I. Right? Second step, step 2 is to use Ohm's law. To use Ohm's law. Ohm's law stays V equals to IR, and from here you have to calculate the value of R, that is V by I. So from here V by I is equal to R. Here we have V by I, that is equals to R. Right? Now we know that if, see, slope is equal to R, so that means if resistance is more, slope is more. The one graph which has more slope will have more resistance, right? The graph which has more slope will have more resistance, right? More resistance. So in the case of resistance, now let me know the slope of A is more than slope of B. That is very, very easy. Slope of A is more than slope of B, right? Now from here slope is equal to R. Slope is equal to R. That means resistance of A will be more than resistance of B. Correct? Understood? And we know which combination has more resistance, series or parallel? Which combination has more resistance? Okay, A is maximum series, B minimum parallel. Very good. The resistance, the combination which has more resistance, that will be series. That will be series, and the combination which has less, that will be parallel. So A will be series, B will be parallel. A will be series, B will be parallel. Done? Anyone has any doubt? Okay, let's move on to the next question. Next question, we have 3 cylindrical copper conductors along with their phase areas as A by 2, 2A, and length L, 2L and L by 2. Compare the resistance, which one will have highest resistance. Now I told you the hack, right? So let us do this with the hack. Let me know what is the answer to this solution. Thank you, Sharmaji. I'm so glad you are understanding. Thank you, Ankita. Okay, let me know using that hack. The hack I told you, that hack, but remember, you have to remember one thing very carefully. Everyone listen to me first before solving. The hack we used was for diameter. Here directly area is given. Directly area is given and length is given, not diameter or radius. So you don't have to square it. Okay? Done? Let me know now the answer to this question. We have 3 cases. We have 3 cases. Oh, thank you, Roshan ji. You also study very well. So start studying very well. Okay, I also want to say that आप बहुत अच्छा पढ़ते हो. Okay, let me know. We have 3 cases. Done? We have 3 cases. Now I want you to tell you guys that if you do it on a single page of paper, it will make the confusions very less. Okay, yes, just a minute. First case, let me write it. A1, first case number 1, A1 is simply A, A2 is A by 2, A2 is A by 2, A3 is 2A, okay, and L1 is simply L. Where was it? What did I do? Okay, L1 is simply L, then 2L, then L by 2. L1 is simply L, then L2 is 2L, then L3 is L by 2. Yeah, you have 3 cases. Yes. Okay, you are giving the answer as second case. Okay. I thought you are asking what is the second case. Okay. We have the question. What is the question? Compare the resistance. Which one will have highest resistance? We have to find highest resistance. Right? Now, first let me know if this comes as MCQs. Okay? If this comes as MCQs, then what will we do? We have R equals to rho L by A. So we need, if we want highest resistance, we need length as highest and we need area as lowest, right? Out of these 3, which one has highest length? That is 2L, right? That is 2L. And which one has least area? That is A by 2. That is A by 2. So for MCQs, can you clearly see we solved it under a minute? We solved it under a minute, right? So the length with the longest length and area with the least length will give you highest resistance. For highest resistance, you need a length that is highest, that is longest. For length, you need the longest length and you need the shortest area of cross section. Shortest area of cross section or the least area of cross section, right? In both these cases, we had length as the highest length was 2L and the shortest area was A by 2. Understood? Ankita, she explained very well. Okay. Morning lectures. What time you want me to take lectures in the morning? Ma'am, not too dangerous hack. Okay, Sharma ji, that is great. I'm very happy that you find this hack very great. Okay, now if they ask you this question in long form, in 2 marks, 3 marks, okay, then you have to completely solve it. There is nothing in this, right? R1 is rho L1 by A1. Now keep in mind, they have asked you 3 cylindrical copper conductors. Now they have told this is a copper conductor, so both for 3 of them the resistivity will be same, that is rho. So R1 is simply rho L by A, right? R2 will be rho L2 divided by A2, right? So rho is same, L2 is 2 into L, area is A by 2. This goes up. So R2 becomes 4 rho L by A, right? And similarly, R3, rho L3 by A3, and this will be rho L3 is L by 2, area is 2A. So this comes down, this will be rho L by 4A. and R3. So which has highest resistance? Remember what you have to answer, highest or least. Highest resistance is R2. So R2 will be our answer. Oh, okay, Yuvan, you're in Gulf. Okay, what time you want me to take the lectures? Tell me the exact time, okay, then I'll talk. एनर्जी में जो मंथली बिल निकालने का क्वेश्चन आता है वो, हाँ, आई हैव दैट क्वेश्चन, शर्मा जी, डोंट वरी. Okay, let's move on to the next question. We have lots of questions like this. So now this question I'm giving you as homework, okay? This question is your homework because we solved this kind of questions before as well. What is given? A wire of given material having length L and area of cross section A has a resistance of 4 ohm. So resistance is also given, right? 4 ohm. Find the resistance of another wire but of same material. The wire is of same material, so ρ1 will be equal to ρ2 equal to resistivity remains the same. Having length as L by 2 and area is 2A. You have to find the resistance. Can you find this question or not? Which question you want? Which question you didn't understand? The previous one? This question, see, in this question you have just one formula, that is R equals to rho L by A, right? They have asked you to find the highest resistance, right? They have asked you to find the highest resistance. Now if you want highest resistance, if you want resistance to be high, you need a large length and you need a small area. You need a large length and you need a small area, right? Now we have three cases. L1 is L, L2 is 2L, L3 is L by 2. Which one has the largest length? Okay, L2 has the largest length. But we also have to see the area. We have to see least area, right? Shortest area, longest length. Because length is directly proportional to resistance and area is inversely proportional to resistance, right? Correct. So we need least area to get more resistance. Which one has the least area? A by 2 or 2A? We have A by 2, right? So this gives us the highest resistance. Understood now, Yuvan? R3, yes, R3 will be the least resistance, TJ Vlogs. Okay, understood. Very good. Now next question, we have the answer as 1 ohm. I saw one answer as 10 ohm as well. Okay, Yuvan said 1 ohm first. Okay, so the answer, yes, answer is 1 ohm. Answer is 1 ohm, everyone. Okay? Done? Yes, TJ Vlogs, R3 will be the least resistance. We will the question or not? What does that mean, Ankita? Yes, I am listening to Ankita's bath. Okay, Roshan ji. Okay, let's see the next what we have. We have a very important thing to do. First, go like the session. Down there, you can see a thumbs up. I know you can all see that, but go press that, okay? Like the session if you are acknowledge our efforts. If you are acknowledging our efforts, we are bringing you lots of questions, okay? So go like that session and tell me that, ma'am, we have liked the session, and subscribe the channel as well. Okay, next we have actually I think this slide got a little late, but we know R is the formula of resistance is rho L by A. We can clearly see it is directly proportional to length, inversely proportional to area of cross section, and depends on resistivity of the material. Resistivity of the material. Now, temperature. How does it depend on temperature, right? You can get a question, kind of question like this, Ankita, okay? Okay, for temperature, see, for temperature we have two cases. First is metals or conductors. Mainly you will write conductors, but in conductors metals are good conductors, okay? Second, you have either semiconductors, or insulators. These carry electricity very easily, these does not. That means they are good conductors of electricity, they are bad conductors of electricity. Done? Yes. So for metals, resistance is inversely proportional to temperature. That means as the temperature increases, resistance, sorry, that is my mistake. Resistance is directly proportional to temperature. That means as the temperature increases, resistance increases. As the temperature increases, it gets more hard for charges to flow into the conductor. Temperature increase, resistance increase. Very good, Sharma ji, but that is the case of conductors only. Okay, now in semiconductors or insulators, resistance is inversely proportional to temperature. That means if temperature increases, resistance will decrease. Here, if temperature increases, resistance also increases. In conductors or insulators, temperature increases, resistance decreases. Okay? Okay, everyone, understood? Okay, let us move on to the next question. We have combinations of resistances. We'll do questions on this, okay? Yes, Ankita. See, this kind of circuit in which resistances are connected one after the another is a series combination. We all know that. And this kind of circuit in between 2 points, more than 2 or one resistor is connected, that is a parallel circuit. Now, very important point, very important. In resistance, current remains the same. Current remains the same. Voltage is different. Voltage is different, right? And in parallel, current is different. That means current divides. It divides in between different resistances and voltage remains same. Done, everyone? Yes, I saw that question, Sharma ji. So resistivity, okay, we'll talk about that. Resistivity is more for, if resistivity is actually with how much strength a conductor or a material can provide the hindrance to flow of charges. So more the resistivity, less easily the current can flow. More resistivity, that means with more strength, that conductor is opposing the flow of current. So the material which has more resistivity will be insulator, which has less resistivity will be semiconductor, which has even less resistivity will be conductor. Okay? Okay, everyone, now focus on this. A hack to remember this as well. Do you know SI units? Do you know SI units, right? So, in series, current remains the same. Current remains same. Understood? Hi, Maz Ali, how are you? In series, current remains the same. SI unit. Do you remember SI units? So from SI units, series, current remains the same. And just invert it. Series, the opposite of series is parallel, right? The opposite of series is parallel. The opposite of current, not the opposite, but in this case, other than current, we have voltage. So in parallel, voltage remains the same. Understood? Now, the hack. Oh, you are are a student of 10th class. You got leave from school today. Oh, to study, to prepare. Okay, understood everyone? Everyone understood? Hello ma'am. Okay, Kalai. Okay, let's move on to the next question. We have the question on combination of resistances. Can you solve this question? I'll read this question. I'll give you a hint on how to read the question. First part, how to read the question. Yes, Atif, what happened? Okay, the first is given 4 wires, okay, of equal length and of resistance 15 ohms. We have, so as we read, we write, okay, 4 wires, they have equal length, right? They have equal length and their resistance is 15 ohm, okay, forming a square. So 4 wires are forming a square, right? And all those wires have 15 ohm resistance. 15 ohm resistance. Done? We are writing, we are making the diagram as we study the question. Okay? The equivalent resistance between two opposite ends of square. Two opposite ends of square. That means, let's say this, and the opposite one is this. So this is A, this is B. We have to tell them what is the resistance between A and B. Can you find the answer or not? Hi Rohit, how are you? Can you find the resistance or not? How is your preparation going on, Rohit ji? Yes, Ankita. B, Sharma ji is saying B. Okay, do we have any other answers? This question is good. Okay, Ankita, then give the answer. Rohit gives the answer as B. Maz Ali also B. Sarmaji also B. 30 ohm and 30 ohm may parallel. Yes, very good. Yuan is giving 15 ohm. That is B, right? Okay, let's solve this question. The question is very, very simple. We are starting with the basics, right? So this is 15, 15, 15, 15. These are the 2 points. So these are the 2 points between which we have to find the resistance. So let's name them R1, R2, R3, R4. Can we clearly see that R1 and R2 are in series? Right? They are in series, and similarly R3 and R4 are also in series. So their combination will be added. R12 will become R1 plus R2, that is 15 plus 15, that will be 30 ohm, right? And R34, that will be R3 plus R4, that will be 15 plus 15 equals to 30 ohm. Great. Now these two are in parallel. Both of these, between 2 points, more than 2 resistances are connected. How will we make this circuit now? This is one point, this is another point, this is another point, and this, let's say, this is the resistance now. Something like this, okay? I made it in the same manner, but something like this. But this is 30 and this is 30. Now these two are in parallel, right? To solve parallel, we know the formula, that is 1 by R12 plus 1 by R34. Mind you, we are also studying the presentation, how to present the question as well, okay? Ma'am, also how do you know opposite adjacent resistors and not the ones parallel to each other? I didn't understand, Yuan, what are you trying to say? But I think I get it. I'll explain in a bit, okay? They are in series of both of them. You have to plus to make the parallel, then divide. Yes, exactly. Let me tell you, okay? Yes, Sharma ji, myopic eye, hypermetropic eye on the numerical will definitely come in board. Okay, so now they are in parallel. That will be 1 by 30 plus 1 by 30, and that will be 31 plus 1 equals to 2 by 30. That will be 1 by 15. So RP will be 15 ohm. Now Yuvan have a question. How did I know that those are in parallel or in series? So listen carefully, Yuvan. Okay. For series, how do we differentiate between series? If the resistances are connected one after the other. How do I differentiate? Listen carefully. See, let's take this A point, this B point, this C point, this D point. So between A and B, only one resistance is there. Between C and D, only one resistance is there. But if I take A and C, between A and C, two resistances are there, right? So if between 2 points I only have one resistor, between 2 points, then that is a series combination, right? But if, let's say, this is in parallel, okay, parallel. Now let's say this is a resistance, and this is a resistance, and this is A and this is B. Now between A and B, how many resistances are there? Ma'am, in my pre-board I got 65. Okay, that means we are here to study, to prepare. Okay, A, B. Now between A, B, we have three resistors. Look, in between here also we have two resistors, but between that we have another point as well. So two adjacent points, we only have one resistor. If you say, ma'am, this is also a point, this is also a point, but yes, in between C and D we only have one resistor. In between A and D we only have one resistor, C and B one resistor, but between A and B we have more than one resistor. Between 2 points we have more than one resistor. Okay, Yuvan, that's not what you were asking. Sorry for that. What are you asking? Okay, hi Ravi Ranjan. How are you? Yuvan, what are you asking then? Till then, I think I read a doubt of Sharma ji as well. What was your doubt, Sharma ji? I got 80 in pre-board boards. मैं पता नहीं. Definitely you will get great marks, Rohit. Don't worry about that. Why? Because you are consistent, right? You are studying regularly. Everyone here who is studying regularly, who is improving, if you think today you learned something new that you didn't know yesterday, then you are on the right path. Okay? Yes, Ankita, if you just write the formula, you will get half marks. Sharma ji is asking, how do we know what we need to? Are? Sharma ji, your question got mixed up. Your ma'am didn't give you that marks. It's fine. They are just trying to prepare you for the final. Okay. Even if your teacher didn't give, that is her way or his way of teaching you that you have to complete. But in boards, you will get the marks. How do we need to take U in myopia, hypermetropia? V is given, but object this is. Sharma ji, okay. Wait for few minutes, few time. I'll tell you, or I'll come live in the next live. I'll be covering light and human eye as well. Okay, I'll tell you, just wait few minutes. V and I graph, wait, we taught V and I graph in very depth. Where is V and I graph? Where is V and I graph? Okay. V and I graph, we have, where did it go? Where is the V and I graph? Okay, I'll teach you again. Just a minute. See, V and here is our V and I graph. We have two kind of graphs. Either V can be on y-axis or and x can be on I can be on x-axis, or I can be on y-axis and V can be on x-axis. So in both cases, the first step, we have two steps. The first step is to find the slope. Okay, the first step is to find the slope of the given graph. Slope of the given graph, the graph that is given to you in the question. Okay, second, you have to use Ohm's law. Second step, Ohm's law. So that will be V equals to IR, right? From there you have to calculate, from there you have to find the resistance. Just nothing, R equals to V by I. Now you have to compare this with slope. Slope will be either V by I or I by V. If the slope is V by I, this will be equal to R. If slope is I by V, that will be equal to 1 by R, right? Now if slope is R, then if slope will be more, for more resistance. But if slope is 1 by R, that means more resistance, less slope, right? So the slope, the graph whose slope will be more, will have less resistance, right? And less resistance is for parallel. Ma'am, if we name the square ABCD, how did we take DAB and DCB in series? Okay. Where is that question? Let me go to that question. The question. Here. Okay. You are asking that if we take, let's say this is a square, this is A and this is B, right? This is 15, 15, 15, 15. Okay, let's not name it as B, let's name this as B, this as C, this as D. You are saying why we took ADC and ABC in series, right? See, because we have these 2 points. That's why I was explaining you the question where I was explaining you this part, that between 2 points we have multiple resistors, then that is parallel. Okay, so similar thing happens here. Between 2 points A and C, we have 2 resistances, but this is a wire. So can I say that this is a straight wire and now this is like this? So this wire is in series, right? This was a straight wire, but I bent the one half. So this wire is in series. It's not in parallel. So these 2 wires are in series. They are one after the another, right? I told you that between A and C, if I have one B point, so A and C, these 2 are in series. That is why I was explaining you this, Yuvan. This concept I was explaining you. That is why, because A, B, C, between AC I have one more point. So these 2 are in series. But here A and B, we don't have another point. These 3 resistors are between 2 points. But these 2 resistors are between 2 points, but there is one more point in between them. Right? So, where is it? So between A and C, if I lay it down, if I open this will be like this. This will be like this, A, B and C. Now tell me, are they in series or not? Angle. Atif, which question did you study? Can you tell me the question? And we can solve the question if they are asking the angle. Angle is just slope. Slope is tan theta. You studied in maths, right? So that's why they are taking the angle. Okay? Okay, Yuvan, understood. Okay, now you understood. And see, between, if I open this will be A, D and C, right? These 2 are in series. This is in series, this is in series. But between A and C, now if I solve this will become A and C, and this will also become A and C. Now see, between those points, between 2 points, 2 resistors are there, 2 resistances are there, right? Done now? Okay. Okay, the next question. Which answer are you giving? Who gave the answer? Sharma ji gave the answer. Yes, it is in series. Okay, Yuvan. Understood, right? Do you have any doubt now about this? Okay, let's move on to the next question. Find the current flowing through the given circuit. Find the current flowing through the given circuit. I'll explain you the steps and then we'll solve it. Then you solve it, then I'll solve it. Okay? First step, every time you get a combination of resistors. This is combination of resistors, right? This is a combination question. Every time you get a combination, step 1 is to calculate R equivalent. That means your whole circuit should just contain 1 R. Till then you have to calculate R equivalent. Step 2 is to calculate current. That we have to do in this question. We have 0.5 ampere. Atif is saying, Yuvan is saying 0.5 ampere. Sharma ji is also saying. Sharma ji is saying 8 ohm, 4 volts. So according to Ohm's law, it will be 0.5 ampere. Very good, very good. Okay, let's solve this question. First, we have to find R equivalent. Now, while finding R equivalent, keep in mind, see very carefully. While calculating R equivalent, this is still a normal circuit. First, you have, if there is a bigger circuit, how you have to do? First, you see parallel resistances. First, you solve parallel resistances. Then, you solve series resistances. Okay, then solve the series one. So in here the parallel one is what? This part is parallel one. Let's name it as R1, R2, R3 and R4. So R2 and R4 are in parallel, right? So let me calculate R2, this combination, right? This is 2, this is 2. 2 and 2. Yes. So this will be R 1 by R24 will be 1 by R2, 1 by R2 plus 1 by R4, right? That will be 1 by 2 plus 1 by 2, which will be 2, 1 plus 1, that will be 1. That will be 2 divided by 2 equals to 1. So R24 will be 1 ohm. Done till here. Now we create the circuit again. First step is to calculate the parallel one. Then second step is to recreate the circuit. Very important presentation tip. Remember this. I know you can solve these questions, but presentation is equally important. Yes, Sharma ji. After this question, we'll get the break. Okay. So you have to create the circuit again now. Now the circuits, these two in parallel, they will be converting it into single resistance 1 ohm, right? So this circuit will be simply this now. This circuit will become something like this now. Now this is 1 ohm, this is 1 ohm, we calculated, right? And this is 6 ohm. Now this is in series. This is simply in series R1, R24, R3. So can we just add them? So R equivalent. Now R equivalent will be simply R1 plus R24 plus R3. This one R1, R24, R3. R1, R24, R3. This is 1, 1, 6, right? So you will add 1 plus 1 plus 6, that will be 8 ohms. So R equivalent will be 8 ohms, right? So we are done with the first step. We are done with the first step, okay? The second step now is to calculate current using Ohm Baba's law, okay? Using Ohm's law. So second will be, मैम जब एक है पैरेलल में रेजिस्टेंस सेम हो तो जितना भी रेजिस्टेंस हो उससे रेजिस्टेंस को डिवाइड करना. Yes, Sharma ji, very good. I'll also, let me explain that also, right? That's a good point, very good. So step 2, Step 2 will be calculating current using Ohm's law. Ohm's law is V equals to IR. We are given V was 4 volt, right? V was 4 volt. V was 4 volt. So V is 4. I we have to calculate. R is 8, right? So resistance is V divided by I. No, we have to calculate current. We have to calculate current. I is V divided by R. V is 4 volt. R is 8. That will be 1 by 2. Everyone, very, very, very good. You all solved it very correctly. This is a CBSE previous year question, so you are solving CBSE board question, right? Okay. The point which Sharma ji is saying, I realized I didn't even tell you guys the exact formula for series and parallel, but you are very smart, I know. So for RS, we know we add all the resistors, we add all the resistances, and for parallel, we know 1 by Rp is 1 by R1 plus 1 by R2 plus 1 by R3. Now it is a special case. We have a special case, a special guest, in which if all the resistances are same, if all the resistances, if the value of all the resistances are same, then that means R1 equals to R2 equals to R3, right? So RS becomes what? R, and we'll take it as R, right? So in place of R, can I write R plus R plus R, right? That will become 3R. Now if I have N resistances, that will become NR, right? So RS, if resistances are same, that will be N into R. If resistances are same. If we do same thing for that, then that will be 1 by Rp equals to 1 by R plus 1 by R plus 1 by R. That will be 3 by R, right? If I have N till N, 1 by R plus 1 by R plus 1 by R, and it goes on till N terms. So that will be N by R, right? But this is 1 by Rp. So Rp will be R divided by N. So that means if in any question they are given 5 same resistances, find the series combination, that will be 5 into R. If parallel combination, R divided by 5. Okay? Done? Oof. Everyone understood? Any doubt? Any doubt till here? Okay, we'll take a 5-7 minutes break, okay, and then everyone will come back, okay. Yes, we have roses from Sharma ji, thank you. Very good, all of you. Okay, we'll come in 5 to 10 minutes, okay. Okay, let's come at 1. Done? This is 12:50 now. We'll meet again at 1. Done? Everyone? Okay. No ma'am, vlogs is saying. What no? No break. You don't want any break. I want a little bit of break. I'll lose my voice otherwise, okay? We'll be back in 5 to 10 minutes, okay? Done? I'll be here. I'll be back in 10 minutes. Everyone. Hello, mic check. Hello, everyone. I am back. Break finish. Yes, Sarma ji. Break finish. Let's study. Chill. It's not some hectic class. Okay? Take it as a break as well. Okay? Okay, everyone. Come back to your senses. Everyone. Break is over. Okay? Let's see what else we have. We have one more question. Can you do this now? No 20 minutes more. No. After some time again, I will either complete the live or I'll give you the break. Okay? But can you do this question or not? Anyone here who wants me to solve this question, I'll solve this question. Otherwise, it is a homework for you. How will we do this? See, let's name it as R1, R2, R3, R4, R5. Okay. Now, can you see R1 and R2 are in series? I'll write everything, then you'll just have to do the calculation. Okay. R1 and R2 are in series, right? So you can simply solve them and the resultant will be named, we'll name it as R12. Okay. Okay, Prakash, come easily, it's fine. I'm here. If you have any doubt, I'll explain again. Okay. Take your 5 minutes. Now, R1 and R2 are in series. Then R12 and R5 now are between two single points, right? Two single points, two resistors. So R12 and R5 will now be in parallel. We'll name it as RA now. Okay? Now RA, R4 and R3. RA and R3 and R4 will be in series. Can you solve it now? R1 and R2, you have to add them. R12, their resultant and R5 will be parallel. You have to take the LCM. And then the resultant R4, R5 and R3, RA, those will be in series. Okay? Okay, Sona. Okay, anyone has any doubt? 8 ohm is the question, is the answer of Sharma ji. Yes, 8 ohm. Yes, I remember. The answer is 8 ohm. These are not in the option, so the option will be none of the above. The answer is 8 ohm. Very good, Sharma ji. Okay. The answer is option number D, that is none of the above. The actual answer will be 8 ohm. Okay, done? Okay, let's move on to the next question. Next thing, what is the concept? Yes, this is again on a little bit of a different concept. Read the question carefully. Find the maximum and minimum resistance that can be made using 4 resistors, each of 10 ohm. Now we have to combine 4 resistors. Each of resistance 10 ohm. We need to combine them in such a way that in first case we get a maximum value of resistance. In second case we get a minimum value of resistance. How will we do that? How will we combine them if we need maximum resistance? How will we combine them if we need minimum resistance? Batao. Let me know. Parallel 2 ohm and equivalent. So total is 3 plus 3 plus 2. Yes. Correct. Sharma ji. Sharma ji is saying 2.5 for minimum, okay, and 40 for maximum. That is Great, but I want you to answer how. Yes, exactly. Series in maximum. For minimum, we need parallel. Hi TNG. TNG is new to the channel. Welcome to the channel, TNG. 2 or 3 things you can do. Subscribe if you want. There is a link in the description to join the WhatsApp channel. That is important. So go join that. Okay. Maximum series, minimum parallel. Very good vlogs. Okay. Very good. Karan Singh Mohali is also back in the live session, and they are saying parallel minimum, series maximum. Very good. 40.4 Rohan. Okay, let's see. For maximum, we know we have to combine them in series, right? And since we talked about it, all resistances are same, right? So RS will be N into R, right? N is the number of resistances, that is 4. So that will be 4 into 10, that is 40 ohm. You can use this in the exam. They won't cut your marks. So you can use this. But you have to write that all resistances are same. All resistances are same. Right? And then for minimum, we need to connect resistances in parallel. That means 1 by Rp will be N by R. Why? Because all are same. Okay? Then you can write 4 divided by 10, which will be 1 by, wait, this is 1 by Rp, so reverse it, and that will be 10 by 4, which is 2.5. So everyone, each one of you is correct. Very good. Hi ma'am. Oh, hello Death God, how are you? Welcome back to the session. Okay, let's move on to the next question. Any doubt in this? Let me know. Next, we have advantages of series combination. This can also be a question. This can also be your question of 1 or even 2 marks. Done? What are the disadvantages of series combination? That is, my friend, first, if one device since devices are connected one by one, if one device in series fails, all the devices in that series, in the continuation, will get disconnected. Example, your Diwali lights, those fairy lights. Okay. Second, we have different devices need different current to run, right? And we saw, remember, SI unit. That means in series, current remains the same. So that means in series, if my appliances are connected, if my refrigerator and charger are connected in series, they will get same current, but they don't need same current. They need same voltage. They need different currents to function, and hence that is the disadvantage of series combination. Okay? All appliances in series get same current first. Very good. Yes, also another, we can't on or off devices separately. Karan is saying very good. For appliances to run separately, okay, that can come in the first point as well, but you can write the third point. For each appliance to run individually and simultaneously, you have to connect them in parallel. That cannot be done in series. Okay? Yes, there is no concept of equivalent voltage in parallel, because in parallel all the resistances, all the appliances will get same voltage. So that is equivalent voltage. Yes. It will be of same voltage. Oh, I'm teaching wrong. What am I teaching wrong? RNG. Okay. Next, let's move on. The next concept is electric power and electric energy. This is very important. Do not talk like this, I will request, because even if you know, that doesn't mean you know all the questions, and even if you do know, you just revise it again and again. That's how you master something. You revise the same thing again and again. Okay, that is how you master something. So even if you know it, you still need a revision. You still need the practice again and again and again. Okay, so Sharma ji, you are doing a good job, and Anmol ji, it is okay. Okay, okay, we have the two very important concepts. First is electric power. Electric power, we have studied about work, right? So the rate of doing work is called power. The rate of doing work is called power. That means work done upon time. The rate of doing work is work done upon time. It is equal to power, right? Or the rate of consumption of energy. Now its SI unit is watt. Its SI unit is watt, right? Then we have a very important formula, power equals to potential difference into current. How did we get this formula, ma'am? Do you want me to tell you? Power equals to work done upon time. We studied from potential difference that work done or potential difference is work done upon charge, right? Potential difference is work done upon charge. So work done will be potential difference into Q. So can I write V into Q divided by T? And we know Q equals to I into T, right? Can I put that here? V into I into T divided by T equals to power. So this cancels out. Power comes as V into I. Very, very important formula. Understood, everyone? Understood, everyone? Do you have any doubt? Okay, next, this is all about power, and the 1 watt of power is equal to 1 volt of potential difference when 1 ampere is of current is flowing through that conductor. Okay, power equals to V into I. Very good. That's God Karan Singh Mohali. Okay, then coming on to electric energy. Now electric energy is the product of power into time. Okay, Sharma ji was asking numericals on electric energy, so we are going to do numericals on electric energy. Take out your pen and copy. Okay. It is the product of power into time. Now in here we'll take time and hours. We'll take time in hours. This is very important point. Do not convert time into seconds for electrical energy. It is taken into hours. Now the formula, the SI unit is actually kilowatt hours. It is kilowatt hours. The SI unit of electric energy is kilowatt hour. Okay, so this is kilowatt is power, watt is power, so kilowatt is also power, into time, that is R, so that is power into time. Okay, yes, pen copy is also needed. 1 kilowatt hour is 10 raised to power 6. Yes, that is a typing error, Sharma ji. This is 10 raised to power 6. This is 10 raised to power 6. So 1 kilowatt is equal to 1000 watt. Definitely into time is 3600 seconds here. So if you want to convert 1 kilowatt hour into watt seconds, that will be this conversion. So 1 kilowatt hour is equal to 3.6 into 10 raised to power 6 watt seconds. Okay, two very important things, and you can write watt seconds as joules as well. Done? Anyone has any doubt? Okay. The rate of flow of charges is the definition of electric current. Okay, Rani ji. Okay, let's move on to the next. We have a very important question. The question we have is an electric iron of 1500 watt. Now, since it's a watt, that means it's power. So we are given with 1500 watt and voltage as 200 volt and a flashlight of power 500 watt, and voltage as 200 volt used in our homes. The rating of fuse to be used should be what? The rating of fuse should be used, will be what? Magnetic effects of electric current will do in just some time, Rohan. Okay? Maximum 15-20 minutes. Okay? Now, can you tell me what is the rating of fuse that should be used in this case? So, first you have to do, we can clearly see this is ampere, right? So, you have to calculate current. Even if you don't know, you can see the options, it is ampere, so you have to calculate current, right? So, we just studied a very important formula, that is P equals to V into I. P equals to V into I. So, I can easily calculate current from here, that is P divided by V. P is 1500 divided by voltage is 200, right? So, this cancels out with 2, that will be 7.5. So, in this case, current will be 7.5 ampere, right? In the second case, 15, that's God is asking. Yuan is saying 15. Okay, let us see. In the second case, you also have P equals to V into I. I will be P divided by V. In this case, we have 500 divided by 200. That will be 2.5, right? Easy, very easy calculation this is. So, I is 2.5 ampere. Correct? Now, you have to add these two currents because fuse is connected in series. You have to add all these currents. Why we are adding all these currents? Fuse is connected in series, but all my appliances are connected in parallel in our households. That means different currents. Now, total current will be 7.5 plus 2.5. 7.5 plus 2.5 will be my total current, right? So, that will be 10 ampere. Now, what should be the option? Should the fuse have 10 ampere or more than 10 ampere? So, in general, listen. In general, if you get the answer as 10, now 10 ampere is the current used by these appliances. In general, if you get the answer that appliances are using 10 ampere, that means fuse should have little bit more rating than, yes, exactly, that's good. Fuse will have a little bit higher rating than the actual current. Now, if here you will had a option as, let's say E option is 12 ampere or F option is 13 ampere. Then what will be the answer? Then the answer will be 12 ampere. So, the closest value to your current, more than your current, but closest. It should be more than 10 but closest to 10, that will be 10 ampere. But here we don't have, that will be 12 ampere, but here we don't have these options. So, just after 10 ampere, what is the value I have? We have 15 ampere. So, 15 ampere will be the actual answer. Okay? Yes, Yuan Sharma ji, it will be 15 ampere. Very good. Okay. Why are you dividing with 5? Why are you dividing with 5? Okay, it's fine. No worries. Now you know how to do it, right? 10 will be the actual current, but the value of fuse will be little bit higher than the actual current. So, that will be 15 ampere. Okay. Next, we have one more question. See, you have a question to calculate for daily hours and all that. The rate, right? Now, okay, we don't have rate here. Sorry for that. I have one more question for the rate for you. An electric motor rated 2200 watt. So, power is 2200 watt, right? Is connected to 220 volt mains. So, voltage is 220. Right? Find the current drawn from the mains. Can you clearly see what we are doing? We are writing as we are reading. So you have to calculate current, and then electrical energy consumed if motor is used for 5 hours for 6 days. 5 hours for 6 days. Very important. Now let me know the answer to this question. Oh, we have already have the answer. I didn't even stop reading the question. Finished reading the question. Death God is saying 10 ampere. Sharma ji is saying 10 ampere. 10 ampere. Yuvan is also saying 10 ampere. Vlogs is also saying 10 ampere. Very good. Very good. Very good. Okay, let us see if you guys are correct or not. This is very basic. Okay, you guys are really smart. P equals to V into I. Very basic formula we used. P is 2200. Voltage is given as 220 into current. Current will be 2200 divided by 220, and this will be 110. Current will be 110 ampere. How are you? Oh, sorry. That is my mistake. Not be. It won't be 110. It will be 10. Very good. That is a really silly mistake. I am really sorry for that. Yes. 10 ampere. Abhinav is saying. Very good. All of you. Very good. Now, next we have to calculate electrical energy. Now, electrical energy, the formula of electrical energy is what? Power into time, right? Power into time. Now, power is given as 2200. 2200. Now, time. Time is 5 hours, and we need power and we need energy. For energy, we need time in hours as well, but it is for 6 days. So total hours will be what? 5 into 6, right? That is 30 hours. Now electrical energy is power into time, but remember in here we need power in kilowatt hours and time in hours. Oh, power in kilowatt and time in hours. Right? Now power is 2200 watts is given. 2200 watts. To convert it into kilowatts, we need to multiply it by -3, or we need to divide it by 1000. Right? So power will be 2200 divided by 1000. Now it is in kilowatt. So this cancels out. Power is 2.2 kilowatt. Right? So we'll put this here. 2.2 kilowatt into time is 30 hours. Right? So that will be 6, and here is a point, here is a 10. So this cancels out. 66 kilowatt hours. Very good. Sharma ji gave the answer 66. Very good. That's God. Sharma ji, Aman, Abhinav, all of you are correct. Very good. What is 3.96 10 to the power 7? Vlogs. Yes, 2.2 kilowatt into 30 hours will be 66 kilowatt hours. Very good. Easy peasy lemon squeezy. Yes. Okay, let us move on to the next question. We have, just as electricity is supplied at 220 volt for domestic use in India, it is supplied at 110 volt in USA. If resistance of 60 watt bulb for used in India is R, then that of 60 watt bulb for use in USA will be. We have to calculate the resistance of the bulb in USA. Okay? Let me give you a hint. Let me write the question in an easy way. Okay? See, we have two cases. First is in India, right? And second is USA, right? In India, the voltage is 220 volt. So we will write VI will be 220 volt. But in USA, it is 110 volt, right? 110 volt. Now, resistance of 60 watt. So the power is given as, so power of bulb in India is 60 watt, right? Power of bulb in India is 60 watt. Then that of a 60 watt bulb, power of bulb is same in USA as well. So power in USA is also 60 watt, right? We have to calculate, now resistance of bulb in India is given as R. We have to calculate resistance of bulb in USA. A, fine. You are given the answer A, but I want you to answer how. How? Okay, from now till now, as you answer the option A, option B, C, D, I want you to answer why you got that answer as well, what formula you used, what is the reason. Okay? Done? Okay, so how do we have to solve this? Before that, I have to tell you something very important. We have this formula of power. Now we know V equals to IR. So if I filled IR in place of V, so power will be what? IR into I. That will be, the power will be I square R. Again, a very important formula of power. If I put I equals to V by R, in here, if I put I equals to V by R, power will be V into V divided by R, right? So power will be V square divided by R. A very important, two important formulas of power. Done? Yes, V equals to IR, V square by R. Very good. So what we are going to do, since the power is same in both cases, how you have to present this question? Very carefully look at that. Since the power is same, as power is same in both cases, same in India and USA, so power in India equals to power in USA. V square in India divided by R in India equals to V square of USA divided by R of USA. Now voltage in India was 220 whole square divided by R of India was simply R. V square was 110 whole square divided by R of USA. Right? If we rearrange it, we cross multiply it, R of USA, 220 volt square equals 210 volt square into R. Right? Now if I solve it, it becomes R of USA equals to 110 whole square divided by 220 whole square. Right? Into R. Till here any doubt? Till here any doubt? So R of USA will come out to be what? 110 divided by 220 whole square into R. Correct? This is true, right? Everything is true. Yes. So this cancels out. This is 1 and this is 2, right? So R of U equals to 0.5 whole square into R. So R of U, or you can write 1 by 2. You can write 1 by 2. So this will be R by 4. Understood how to present this question, how to write this question? 5 बार solve किया है. Great. That accounts to revision and preparation. Okay. So this kind of question will come, you will be able to solve it, right? Vlogs. Okay, so the answer is correct, that is R by 4. Let's move on to the next question. We have, now this question I want you guys to solve very easily. Your school is still going on, that is a bit questionable, but it's fine. They must be teaching you, they must be revising you, right? So it's on you, I think. I shouldn't be telling you this, but after January your attendance doesn't really count, and especially 10 days 12 days before your examination attendance doesn't really count. So You can decide whether you want to go to school or you want to sit in the home, watch live sessions and study. Okay? Okay, let's see. A household uses the following electrical powers. First is appliances. First is refrigerator, and it has a rating of 400 watt. That means power is 400 watt, and it uses it for 10 hours each day. Time is 10 hours each day. Each day here is very important. Okay? Then we have another appliance, second one. It uses two electric fans of rating of power 80 watt for each for 6 hours daily. Time is 6 hours daily. Right? This all is given to us. Then calculate the electricity bill for the household for the month of June. How many days are there in June? Tell me, because this is very important. If you wrote that in the month of June there are 31 days, 29 days, that will be wrong. 29 you won't, but 30, 31 you have to decide, right? Nahi ja rahe. That's fine, Karan. Okay, ma'am. Yes, Ishu Radhika. Yes, Radhika. समझ नहीं आया. I am solving it. Wait for a few minutes. I'm solving it. Yes, in June we have 30 days, and remember the days of all the months, because this will be a silly mistake if you do it, right? Okay. So we are using these all things for 30 days. We have to calculate electricity bill for the household for the month of June if cost of electrical energy is 5 per unit. What is the cost of electrical energy? That is 5 per unit. Now let me solve this. Let me tell you how to solve it. Till that time you tell me what 1 unit is equal to. In case of electricity, 1 unit is equal to which value? Yeah, like I think they are trying to make you revise all the syllabus. They must be teaching you in the schools, but I guess that's your call. Okay. Let me know what is 1 unit equal to. 1 unit is equal to which SI unit? Okay, now we have to calculate electricity bill. For that we have to calculate electrical energy first. And how do you calculate electrical energy? That is with the help of power into time. Right? Now it should be, power should be in kilowatt, time should be in hours. Let's see what power is given. Power is 400 watt. Power is 400 watts. So we have to convert it into kilowatts first. That will be 400 into 10 raised to power minus 3 equals to 0.4 kilowatt. Right? So power of fridge is 0.4 kilowatt. Right? And time. So we are using it for 10 hours each day. That means 10 hours for 30 days in the month of June. So that will be 10 into 30 for June. Right? For June. So time will be 300 hours. Correct? For fridge. So what is the electrical energy that fridge is using? Fridge is using power into time. Right? Power is in kilowatts, 0.4 kilowatts. Time is in hours. That means 300 hours. So this come out to be 112. 4 into 3 will be 12. 2 zeros and 1 point. So this will be 120 kilowatt hours. The energy that fridge is using, or okay, we used R for this, right? That refrigerator is using will be 120 kilowatt hours. Correct? Okay, 600 rupees and 144 rupees. Okay, let us see. Okay, this clear? Now we have to calculate the second part. Calculate the electrical energy of two fans. Each of having power 80 and they are running for 6 hours daily. So we have two fans. Remember, not one fan, two fans. So whatever the electrical energy be, power into time, that will be multiplied by 2. Right? So energy, for energy, the power is given as what? What is the power that is given to us for fans? That is 80 watt. Power is 80 watt. To convert it into kilowatt, we will be doing 80 into 10 raised to power minus 3 kilowatt. That will be 0.08 kilowatt. Right? Then time was 6 hours daily for the month of June. That will be into 30. So this will be 180 hours. Right? So time is 180 hours. Power is 0.08 kilowatt. So energy will be what? Energy will be power into time for fan, but for two fans. Right? So 2 into power is 0.08 and time is 180 hours. Right? So that will be 6 8 8 are 64, 6, and then this will be 144, and we have a point that will be 14.4 into 2 electric energy of fan, but two fans. Remember, electrical energy of fans, but we have two fans. Sharma ji, we have two fans here. Okay, so that will be 28.8 kilowatt hours. Right? That is energy due to fan. Done? This is correct, right? We have 80 watt. 80 watt we converted into kilowatts. That will be 0.08 kilowatt. And time is 6 into 30 hours. Right? Oh, wait. We are, yeah, true. Right? 6 into 30 hours. Now this is for one fan. So we multiplied it for two fans. 2 into 0.08 into 180. That will be 2 into 144.4. Right? 28.8 into 5. Okay. So this is, okay, you are telling the rupees. Fine. So this is 28.8. Now, wait, we have electrical energy as 120 plus 28.8. So the total electrical energy will be 28. Where it is? Okay, so total electrical energy will be electrical energy due to refrigerator plus 2 of the electric fans, right? So electrical energy of refrigerator came out to be what? 120. It was 120 plus 28.8, right? 0.8. So this whole comes out to be 148.8 kilowatt hours. This is total electrical energy. Understood? Yeah, you can do like that as well. 600 rupees, 144 rupees, correct. But you can also do add them, because we have to calculate the power for cost for the whole, right? Calculate the electricity bill for the household. So total we have to, correct? So you can add 600 and 144 and write the answer, or you can do like this. Okay? Okay, vlogs. Okay, so now 1 unit, I asked you 1 unit is equal to, it is equal to 1 kilowatt hours. So we have how many units now? We have 148.8 units. That means right? We have 148.8 units. Now the cost of 1 unit was 5 rupees, was rupees 5. So the cost of 148.8 units will be what? It will be 148.8 into 5, right? So this will be 0.4 on that above, 44, 4, 24, 2, that will be 744 rupees. So in total, the household will get the cost of running 1 refrigerator and 2 fans will be 744. Very good, very good. Vlogs, Rohan, Sharma ji, Death God, every good. We need to find the total. See, they have asked you to find the, look here, calculate the electricity bill for the household. If they have asked you the household, you have to add those two, okay? Yes, Rohan also said 744. Great. Okay, Sharma ji. Okay, done with this question. Let's move on to the next. We have heating effect of electric current. That is Joule's law of heating. What is it? When an electric current, read it very carefully. 744 is the answer, Death God. You are correct. Okay. When an electric current, there is a conductor and through that electric current is passing. Very good, very normal. But if that current is passing for a long period of time, we are not switching it off, it is passing. Even if for a normal period of time, that current starts to produce heat. Why? Because of the resistance. Okay, so when an electric current passes through a conductor or a device, the conductor becomes hot, raising the temperature of the conductor. You have seen bulbs. If you touch a fan just after turning it off, you will see it is heated. Or iron is used for heating, right? Energy equals to heat. Yes, you can say that. Heat is directly proportional to the square of current. Yes, very good. So this heat depends on current because it's flowing, resistance I told you, and time as well. On time as well. For more time, if the current is flowing for more time, it will get more heated. If the current is flowing from less time, it will get less heat, right? So very important formula, H equals to I square R into T. Done. And if I use Ohm's law, again one more important formula, that is V square T divided by R. Great. Now SI unit is the same as work done as energy, that is Joule, right? That is Joule. SI unit of heating effect of electric current is Joule. Now very important point, I'll tell you in 1 minute. Yes, so when we use a bulb, right, or we use a fan, what is happening in iron? We have iron, I don't know how to make, whatever, this is iron, okay? Now in iron, we need it to get heated, right? Derive this. I don't really think so, but even if they ask you to derive, you just write it that heat is directly proportional to I, it is directly proportional to R, directly proportional to time square of I, then it is equals to I square R into T, right? And we know V equals to IR, so if I put in place of I, if I put V by R, that will be H equals to V square by R square into R into T. So V will be V square by R into T. That is the small derivation, okay? Now in iron, we need iron to get heated, right? So in iron we use alloys. We use alloys. What are alloys? Mixture of some elements, mixture of some metals. Okay, those are alloys. Why we use alloys? Because it has high resistivity. It has high resistivity. Now, if resistivity is high, resistance is high. If resistance is high, heat will be high, and in iron we need high heat, right? So it has high resistivity and low melting point. If we are giving it heat and if it melts, imagine your iron melting on your clothes, right? So that is not a valid point. So it should have low melting point so that it can bear the high temperatures. Yes, alloys are important for boards. Ma'am, is it V or H? Where? Oh, yes. Sorry. It is H. Very good. This is H. H equals to V square by R into T. Very good, Rohan. Okay, understood? Now, moving on, we have one important question. The question says, what does the question says? An electric iron rated 220 volt and 2000 watt, calculate the resistance of its heating element when in operation. We are given power as 220 volt and we are given this is watt. So, this is watt. So, power is 2000 watt and voltage is 220 volt, right? We have to find the resistance. Can we find it? This is very easy. Heating appliances are made up of microphone. Microphone? Am I missing something? What is microphone? Because of the same reason as alloy. Microphone is this one. No? Am I missing something? Sarma ji? Okay. We can easily solve this, right? Yes. P equals to V square divided by R. Very good. We have P. This will be 2000, right? V we have 220. So this will be the square of 22 divided by R. So R will be 220 into 220 divided by 2000, right? This cancels out, this cancels out. This is 10, this is 11. So 11 into 22 will be 242. You need to do these calculations quickly. 22 into 11, 242. And there is 110 here. So this will be 24.2. This is ohm. Understood? Nichrome. Yeah, I was like, microphone? What is this, new material? Yes, heating appliances are made up of nichrome. Nichrome is also a alloy as well. We can find I by P equals to V by, yes, correct Yuvan, right. 2420, no, we have 242 divided by 2 because these two zeros get cancelled, right? So 22 into 22, or you can cut these, there is 20. So 11 by 10, 11 into 22, 242 divided by 10, 24.2. Okay? Hi Nisha Rajput. Okay. Next we have one question from a sample question paper. What does it say? A complete circuit sorry for that, 1 second. Okay. A complete circuit is left on for several minutes, causing the connecting copper wire to become hot. Copper wires, causing the connecting copper wires, they have become hot. As the temperature of the wire increases, the electrical resistance of the wire does what? Does it increases, remains the same, decreases, increases for some time, then decreases. What is the correct option? Yeah, yes, you can do that, Yuvan. You can do that as well. You can find I, then you can find R, but that is just extra added steps. You don't have to do that. Okay? Yes, very good, Sharma ji. I did tell you in the starting. It will increase the resistance. For copper, see, copper is a conductor. It is a good conductor of electricity, right? So for conductors, resistance is directly proportional to temperature. As the temperature increases, resistance will increase for conductors. Very good, Sharma ji. So it is increases. The electrical resistance of the wire will increase, okay, for conductor. Very good. Okay. Moving on, we have applications of heating effect of electric current, right? So the first is electric bulb. We have seen electric bulb in our houses, right? Although these days we are using LEDs, but in older times we used to use those yellow color bulbs, right? That looked like this. Now you use them for aesthetics, but earlier it used to be pretty common in the houses. So in this wire, this filament is made up of a material called tungsten. Now why it is made up of tungsten? Because we need heat. Tungsten is a material that has very high resistivity and very high melting point, that is 3380 degrees Celsius. These filaments get heated and it emits light, right? The bulbs are usually filled with chemically inactive nitrogen and argon gas to prolong the life of filament. They can ask you what are the gases that is filled in the bulb to prolong their life, or in electric bulbs simply. So that is nitrogen and argon, okay? Geyser and fuse as well. Very good. Next is actually our electric fuse. So what is electric fuse? Electric fuse is a device that protects our appliances. How? By using the concept of heating effect of electric current, right? What it does is, first it is connected in series with the circuit. It is connected in series with the household circuit. Done. Very important point. Then it protects circuits and appliances by stopping the flow of high electric current. What happens is, when there is a fuse, so whenever a high current comes, whenever large current flows, the temperature of fuse increases. The fuse has a low melting point. In alloys, in iron we saw, or in bulb we saw tungsten as high melting point because we want it to burn, but we don't want fuse to burn for such a long time. We want it to melt and break down. So it has low melting point. So temperature of fuse increases, it melts, and hence the circuit is broken. Now if this fuse is in series, it is in series. If one thing breaks in series, the whole circuit gets disconnected, right? Numerical practice, question practice with the revision, please ma'am. Afraid of physics, please ma'am. Okay, killer. For last minute practice, this is last minute practice. We are doing everything, right? We are revising the concept because conceptual questions will be there, and then we are doing the numericals on that as well, right? Yes, geyser has high resistance as like fuse. Fuse, you won't say, yes, it has high resistance, but fuse generally talks about not on resistance but melting point. Fuse has low melting point, and when high current flows through it, it cannot withstand so much heat. It breaks, it melts. As it melts, it breaks the whole circuit, thus protecting our appliances. Okay, so it has low melting point, melts and stops the flow of current. What are the alloys that we use in fuse? That is aluminium, copper, lead and iron. Aluminium, copper, lead and iron, the alloys of these materials. Not these materials, the alloys of these materials. Okay, done. Next we have, we are done with the chapter electricity. Anyone has any doubt in the chapter electricity? No ma'am? Queons are not enough? What is queons? मैम आप तो हमें भूल ही जाएंगे. अरे I won't, Sarmaji, do not do not do this. I won't. I'll never forget my students. I'll never forget my good students. You are one of the good students. Chemistry class will be there, Rohan. Chemistry class will be there. You can go join the WhatsApp channel. The link is in the description. There will be all the schedule of all the classes there. Math, chemistry, SST, okay, everything. इतना काफी होगा, but we have one more chapter, Sarma ji. We have one more chapter. Let's do it quickly. We won't take so much time. I know on electric current I took so much time. I got excited. But magnetic effects of electric current, let's do it very quickly. Okay? Let's do it very quickly. Let's start. Now, magnetic effects of electric current. The first, we have just the plain definition of magnet. What is a magnet? It is a substance, it is a kind of material with which it is an object that attracts materials like iron, nickel, cobalt due to the presence of a magnetic field around it. We have every magnet has two poles, a north pole and a south pole. Like poles attract each other, unlike poles repel each other, just like charges. And magnetic poles, very important point, they exist in pairs. I know this is a easy chapter, you can, but revision never hurts us. Okay? Bye vlogs. Revision will never hurt you. So let us revise it quickly. We won't take much time. Okay? Okay, then next we have magnetic field. And what is magnetic field lines? They can directly ask you this question, what are magnetic field lines? Okay, then the region around a magnet, there is a magnet, the region around this magnet or a current carrying conductor, which we'll study in some time, where its magnetic influence can be felt or within which a magnetic force can be experienced, is called magnetic field. Its unit is Tesla. Very important topic, very important person Tesla ji was. Magnetic field arises from north to south outside the magnet. Very good, Sharma ji. That is true. Magnetic field lines, what are those? They can ask you this question. Magnetic field lines, imaginary lines that represent the direction, strength of the magnetic field. Both direction and strength of the magnetic field. Okay? Done? Yes. We are going to the properties. What are the properties? First is they emerge from north to south outside the magnet, and inside the magnet they go from south to north. That is inside the magnet, and they form closed loops. Okay? Closer lines, strong field. Wider lines, weak field. Correct? Direction at any point is given by the tangent at that point, and these lines never ever intersect each other. Okay? Hi Shaurya, hi, how are you? Yes. Okay? Next we have a question. Next we have a question for magnetic field lines. To draw a magnetic field lines of a bar magnet, we know they can directly ask you this question to draw the magnetic field lines of a bar magnet, of a different kind of structure that we'll study. So for bar magnet, magnetic field lines are closed loops, something like this. Okay? Make sure these are not intersecting each other. Outside north to south, inside south to north, outside north to south. This is a bar magnet. Understood? Okay. We will study about everything. Okay, vlogs, Sharma ji. We'll study about everything. Okay. Thank you, Rajat ji. Okay, let's move on to the next. We have a very important question, very repeated question. Why do magnetic field lines never intersect each other? Why? Because two magnetic field lines never intersect each other, because if the two lines intersect each other, then at one single point, two tangents will be there. And in maths we studied, don't write in maths, and we studied that at one point only one tangent can exist for a single point. That is why Also you can write that on that if there are two tangents, that means at that single point magnetic field line will have two direction, which is not possible, hence magnetic field lines never intersect each other. Okay, yes, tangent. Okay, let's move on. We have magnetic field due to a current carrying conductor. Now here is the story of Hans Christian Oersted came. What did he do? He was doing one experiment one day and he placed no direction impossible. Yeah, two directions are not possible. Yes. So what he did, he was doing some experiment and his compass was left there near the electric circuit, near the current. So he saw a deflection in that needle. So from there what he coined that an electric circuit in which a straight copper wire is placed parallel to or over a compass needle, right? Then if you flow the current in that copper wire, the needle will show some deflection. Hi Nisha Rajput, how are you? It will show some deflection. Now this is the circuit for that. We have a battery, we have a key, and we have a compass. Now when the current flows through it, current flows something like this. When the current flows through this, it is pointed in north-south direction. It points towards west, right? But if I change the polarity of this battery, then now the current is flowing something like this and the needle will point in east direction now. That means if you change the direction of current, the magnetic field, direction of magnetic field also gets changed. यहाँ Oersted Baba, वहाँ Om Baba. Correct. Baba, Om Baba, Oersted Baba. Hi. Tamil point, PTS points. Hi, Mishra, Yash Mishra. Hi, Yash. Ram. How are you? Okay, done. Next, we have the next topic is magnetic field due to a current through a straight conductor. We know that if current is passed through a conductor, it changes the magnetic field around it. Now we study it for different shapes of conductor. First is my straight wire or straight conductor. That is kind of a wire. So this is your wire. If I place this wire something like this inside a cardboard, I put a hole in the cardboard, pass that wire in the cardboard. This is a very important activity of your physics, and they asked you question directly from this, right? Yes, concentric circles. So the magnetic field lines around this straight conductor will be of the shape of concentric circles. How did we do that? We took a cardboard, put a hole in it, passed that wire through that cardboard, then passed the current in that wire. We sprinkled some iron fillings on the cardboard and we saw that iron fillings aligned themselves in a shape called concentric circles. Okay, good. Yes, they will ask the direction. Also, they can ask what is the shape of magnetic field lines. Then you will have to write concentric circles. Okay, Rohan? Yes, iPhone. What is your doubt? Done with this? Now, factors affecting magnetic field strength is directly proportional to current. As the current increases, magnetic field will increase. As the distance decreases, magnetic field will increase. If it's near, the magnetic field will be more, right? And the third is that's it. Distance from the wire. We have a third? No. So one more point, change in direction of current changes the direction of magnetic field but does not affect the magnitude, right? Hi, the gorge one. Do I read that correct? Okay, hello ma'am. Hi, the gorge one. Mera number. I will. Stay till the end of the live session. I'll give you my number. Fine. Chalo. Next we have PQ. Okay, we have a question. Everyone wake up. We have a question. PQ is a current carrying conductor. in the plane of the paper as shown. Find the direction of the magnetic field produced by it at points R and S. What will be the direction of magnetic field at the point R and S? Oh, wait a minute. Before that, let us study right hand thumb rule. Okay? Hi, Tony Stark. Okay, let us study right hand thumb rule. Very basic. If the current is pointed in the direction of, if the thumb is pointed in the direction of current, then the curling of magnetic field, the curling of my fingers, if thumb is pointed in the direction of current, the curling of fingers will give the direction of magnetic field. Right? Now let's do that question. The question is, PQ is a current carrying conductor. I have to tell the direction of magnetic field at R and at S. Let's say the current is in upwards direction. The current is in upwards direction. Now, can you guys let me know what will be the direction of magnetic field lines at a point R? Oh, hi Solo Edits. Yes, I remember you. Welcome to the live. We are on the chapter of magnetic effects of electric current and we are doing it questions. Okay? Hi Deepak, how are you? Okay, everyone. Deepak, the Gorge one, the Solo Edits, Sharma ji, everyone tell me the answer to this question. Radhika, let me know. Nisha, everyone. Left to right. Okay. Think again. Mishra? Yes. Mishra ji, think again. Okay. Let us use, for it we will have to use right hand thumb rule. Okay, the current is in upwards direction, so if I point my thumb in the direction of current, the curling of fingers will give the value of magnetic field. So curling of fingers, it goes inside, so at R, the direction of magnetic field will be into the plane of paper, inside the plane of paper. Okay, that is how you have to write. Done. And at S, it is coming out, it goes in like this and it comes out from S. So at S, they will be coming out of the plane of paper. Done. Same magnetic field. Sharma ji, think again. Yes, exactly, Tony Stark. Correct. Left anti-clockwise. You have to answer something like this. Anti-clockwise will not make any sense. Why? Because they have said that PQ is a current carrying conductor in the plane of paper. They have said that this will be your paper and this is the conductor. So this is your conductor, right? So you have to point the thumb in the direction of current, and if you rotate your fingers, it is going inside the plane of the paper, right? Done. The plane of paper means that your notebook has a page, that is a plane. So that is the plane of the paper. I gave you the direction of current, right? Sharma ji, maybe there is some mistake in this question or I forgot to write. I have given you. They will mention the direction of current. Don't worry. Okay? J Physics. Okay. Oh, you are that Devdas, Tony Stark. Okay, now I know you. Now I remember you. Okay, next we have till here, done. Now, given that R1 is greater than R2, where will the strength of the magnetic field be larger? Give reason. Now, look at this very carefully. We studied that magnetic field is inversely proportional to distance. So if R1 is greater than R2 here, right? They have said that R1 is greater than R2. R1 is greater than R2. That means magnetic field at R1 will be less than magnetic field at R2. Because we studied that magnetic field is inversely proportional to distance. So if R1 is more, magnetic field will be less. R2 is less, magnetic field will be more. So magnetic field at S will be greater than magnetic field at R. Where will the strength of magnetic field will be larger? That is at S. Why? Because the distance of S from the conductor is less. Okay? R की तरफ, yes, R, at R, how you depict that the lines are inside? For inside we use cross, so the magnetic field lines are going in, so we use a cross to depict it, as coming outside, so we use a dot to depict it. How I remembered it? From outside, O of outside, the dot, right? Okay. B, consistency in physics. B, consistency in physics. Right. Very good, Shivam Mishra ji. The magnetic field is stronger at a point which is nearest to the conductor and goes on decreasing on moving away from the conductor. Very good, very good. Yes, iPhone, ask your doubt. Hi, Beauty Yadav. Abracadabra. Okay, let's move on to the next. We have, okay, everyone who is here, go subscribe the channel, and more than that, there is a link in the description. Go join that link. There you will get all the notification about the live classes we are doing, and we are doing massive lives. We are doing all the questions, all the PYQs, MCQs, numericals. So go join that channel and be on time. Okay? Ask the doubt. iPhone. Yes, you have a crown on your name. I can also see. What is that for? I actually don't know. Yes, yes, we are coming to neutral and black wires. iPhone, just wait for a few minutes, okay? Hi, Deepak Kushwaha. How are you? Okay. Like that session, everyone. Like this session. Go on now and like this session. Fast. Yes, subscribe the channel, nahi to fielding set hai. And like the session as well, nahi to fielding set hai. Okay, go. Okay, next we have a very important question. Again, the question is similar to the previous one, but use your mind a little bit. Okay? A constant current flows in horizontal wire. We have a horizontal wire, right? We have a horizontal wire from east to west. So if I place the wire here, the current is flowing in from east to west, right? So this is the direction of current. The direction of magnetic field at a point will be north to south. They are asking at what point? Above the wire, below the wire, behind the wire, in front of the wire. Where will the direction of magnetic field will be north to south? Now, before you do anything, before you give any answer, this is a plane of paper. This is a plane of paper and this is something like the wire is placed, right? So you have to tell me, will it be below the wire? Will it be behind the wire? Above the wire? Directly below the wire means here, not here. It will be here. And this is north, this is south, this is east, this is west. Okay, not above. North is not above. North is here, behind this paper. North is here. Okay? My class was from 11 a.m. Deepak. It states that if you hold a current wire, yes, very good, Prakash Yadav. Sona, I remember. Okay, yes, you are stating right hand thumb rule, which is absolutely correct. Very good. Okay. then the direction of curling of fingers will give the direction of magnetic field. Rule is also called Maxwell corkscrew rule. Okay, very good, very good. Okay, let me know if you can answer this question or not, everyone. If you can answer this question or not. Ma'am, paper. Devdas. What are you doing, Devdas? I'll tell your paro. Okay, let me know the answer to this question. Fast. Fast. Right hand thumb rule. Okay, let us see. That is a very great advice from Anmol Yadav ji. Okay. Where did you give the answer, Mishra ji? Right hand thumb rule, I know. But out of these, A, B, C, D, what is the exact answer? B and A. You are confused between B and A. Okay, let us solve this. Right? The first thing is, this will be your plane of paper. So, north is not above, north is here. If you take this board and you lay it down, so north will be on the here, and south, east and west, not here, right? Just remember this. Now, you place your thumb in the direction of magnetic current, in the direction of current, right? This is current. Now, if you curl your fingers, remember north is here. See, this is the wire, north is here, south is here. So, this is the thumb and you curl your fingers. Where will the magnetic field is directly going from north to south? North to south. It is going below, right under the wire, right below the wire. It is going from north to south. Can you understand? It is going from north to south. Understood? So, the answer is directly below the wire. Answer is B. Vein said B. Yes, very good. Okay? Done? Understood? Just remember, whenever it is written plane of paper, that means the wire is laying down on your sheet, on your answer sheet. Done? Okay. Okay, next we have another question. The resultant magnetic field at point P, yeah, I think you cannot see, but the current is in this direction. It is there. It is given in the question that current is in this direction. Situated midway between two parallel wires, each carrying a steady current in the same direction. It is also written. So, where will be the what will be the magnetic field at point P? Will it be in the vertically upward direction, in the same direction as the current in the wires, 0 in the vertically downward direction? The resultant magnetic field. Okay, let me know what will be the answer of this question, A or B or C or D. C. Sharma ji is saying C because it cancels out from all sides. Done. Let's see if you are right or wrong. This is my right hand. Use your right hand very carefully. Okay, this is your right hand. So, in above the wire, it will be in this direction. It goes in and comes out. So, at point P, the direction is outside, right? Outside, right? For below, it is going in. It is inwards and then come outwards. So, at P, it is inwards due to the below wire outwards because of the above wire, and the magnitude is same, so it cancels out. It will be 0. Very good. 0 is the answer. Done. C. Very good. Very good. Sarma ji, Abhinav, Yash. Very good. Okay. Next we have one more question. Oh, we have lots of questions. If the polarity of the battery connected to the wire is reversed, read it carefully. If the battery connected to the wire is reversed, how would the direction of magnetic field be changed? if the polarity of battery is reversed, how will it affect the direction of magnetic field? Direction of magnetic field. How will it affect the direction of magnetic field? Magnetic field is also reversed. You just said. When did I say? In this question or the previous one? Okay, yes, Sharma ji is right. Whenever the polarity of the battery is reversed, the direction of magnetic field will also reverse. If it is inwards, it will be outwards. If it was up, it will be down. Okay? Then, second, explain the rule that is used to find the direction of magnetic field for a straight current carrying conductor. Just write down the name of the rule. What is the name of the rule that is used to find the direction of magnetic field on a conductor, on a current carrying conductor? Yes, very good. It's good that you remember. Hi Christy, good afternoon. How are you? Ma'am, what about the Iron Man suit? What about the Iron Man suit? If you get AIR 1 to between AIR 5, I'll get you an Iron Man suit. Right hand thumb rule. Very good. Okay. Hello to Siddharth Pathak. Okay. Right hand thumb rule. Very good. Gautam. Right hand thumb rule. Rohan. Very good. All of you are really smart. Abhinav. The direction of magnetic field directly depends on the direction of electric current. Yeah, you can say that. No, you have to define. I just asked you to write the name. That is right hand thumb rule, because we already saw the definition, right? You can write that when you right hand thumb rule states that when the thumb is pointed in the direction of current, the curling of fingers will give the direction of magnetic field lines. Okay? Kartike, hi. Ma'am, fine. Okay. Okay. I'm great, Kartike. How are you? Okay, magnetic field due to a current through a circular loop. We did a lots of questions and we studied about the conductor, straight conductor as well. Okay, Sharma ji. Have your food, have your lunch. Aram se. Okay? Okay, now the same for circular loop, we'll again use right hand thumb rule. Done. The current is in upward direction. The thumb will be in upward direction, and if I curl my fingers, it goes in. Here it goes in, it comes out. Again, it goes in, it comes out. It goes in, it comes out. Magnetic field line. The current is then in downwards direction. My fingers go in and here go out. They go in and goes out. Again, they go in, they go out, they go in, they go out. Now, this is for clockwise current. Right? This is for clockwise current. For clockwise current, inside the loop, the magnetic field will be inwards. And if it is an anti-clockwise current, that means the current will be in this direction. Current is in this direction, inwards, outwards. So for anti-clockwise, inside the loop, the magnetic field will be outwards. For clockwise, inside the loop, the magnetic field, the direction of magnetic field will be inwards. Understood? Anyone has any doubt? Quarantine रहूँगा मतलब? What is quarantine? Thank you, Deepak. Okay, Sharma ji. Go have your lunch. Outwards, yes, Abhinav. Outwards for anti-clockwise, clockwise, inwards. Also, one more thing we have to remember. For clockwise current, current, the pole that will be created will be north pole. Right? That is bad. That will be north pole. So this is kind of an N. So this is north pole, right? If it is an anti-clockwise current, that will be a south pole. No. I gave you the wrong answer. Wait. For clockwise, we have south. For clockwise, we have south pole, and for anti-clockwise, we have north pole. For anti-clockwise, we have north pole. Anti-clockwise, the pole that is visible will be north pole. For clockwise, the pole that is visible will be south pole. Right? I just remember that in anti we have N, so from that it is north pole. Okay? You can remember like that too. Okay, your name is Ruchita. Hi Ruchita, how are you? Thank you for that. Thank you Abhinavji, thank you. Okay, done? Yes, for anti-clockwise it is north, for clockwise it is south. Okay? Okay, next we have the factors. See, the factors on which the magnetic field depends are very important, even for a straight conductor, for circular loop, for solenoid. Right? We studied for straight conductor. For circular loop, it is directly proportional to current. It is inversely proportional to, see, this is written 1 by radius. So magnetic field is inversely proportional to the radius of the loop. More will be the radius, less will be the magnetic field strength. And similarly, for the distance from the loop, as the distance increases, magnetic field strength will decrease. Done? Understood? Okay, then we have next topic, that is solenoid. A very important topic. Solenoid. From solenoid, they will definitely ask you at least one question. Okay, it can be conceptual, it will be conceptual, but they can ask you to make the magnetic field lines as well. Okay. Now, magnetic field due to a current in a solenoid. What is a solenoid? A coil of many circular turns, wrapped closely in the shape of a cylinder is called a solenoid. Okay? Overall, see, inside the solenoid, let me teach you some stuff before that. This is my solenoid, right? The battery, this is the battery. Now, which pole will be which one? The negative pole. The negative pole of the battery will make a north pole. The positive pole will make the south pole. From negative, north. NN. Okay? From negative, north. Main one time or explain kar do. Which one, Himanshu? Which one you want me to explain one more time? Rohan is saying I am from Kerala. Oh, hi from Kerala. Sugamano. Which one you want me to explain again, Himanshu? Okay, understood? This is solenoid and the current will be going in this direction. Right? Now, overall inside the solenoid, what will be the magnetic field lines now? Inside the solenoid, the magnetic field lines will be similar to, first of all, bar magnet. It will be similar to as that of bar magnet. Inside the solenoid, the magnetic field lines will go from south to north, just like normal magnets. South to north. Outside it will be north to south. Outside will be north to south. Done? Correct. Now, inside the solenoid, inside the solenoid, the magnetic field lines will be uniform. Outside, they will be non-uniform, or overall, if they ask you, it is non-uniform. Okay? Okay. Hi Anushka, how are you? Why use insulated copper wire? Because, see, in solenoid, when we wrap it around, it is wrapped very closely. So, these can affect each other magnetic field. That one turn can affect the another magnetic field of another turn. So that's why you have to use insulated copper wire. Right? Thank you, Pramod. I remember, I know your name was different. I am thinking. Yes, Anmol. Okay? Anyone has any doubt? Just a second. Done? Math, no, I don't. I teach physics. Math is taught by Sonu sir. Murtaza sir, you can go watch their sessions. Okay? This is the end. Hold your breath and count to 10. Huh? Ma'am, you know Kerala language? Yes, I know a little bit of Malayalam. I lived there for like 2 months. So I learnt from my friends. Ma'am, my doubt is, why doubts come in mind? Achha. That is the basic thing, that you are alive, that you are asking the world. Why you not? Huh? Okay, chalo. Next we have again the factors on which solenoid, the factors on which magnetic field around a solenoid depends. It is directly proportional to current. Now this part is very important. We know the solenoid is so many turns of insulated copper wire, right? So more these number of turns, less number of turns, more number of turns. Here magnetic field will be more and here magnetic field will be less. Okay, and it is directly proportional, it is inversely proportional to the distance from solenoid. As you go far from solenoid, the magnetic field strength decreases. Okay, done? Hi, hello Kartikeya, how are you? How to increase solenoid strength? You can write that by increasing the current in the circuit, or by increasing the number of turns, or by decreasing the distance from the solenoid. Okay? Yes, Ramesh, I remember you. Hi, Kanan. Okay, done? Ayush, beta, go study. Yes, I remember you, Ramesh. A solenoid is defined as a coil consisting of a large number of circular turns of insulated copper wire. The turns are wrapped closely to form a cylinder. Very good. Okay. Let's move on to the next part. We have a question for you guys. Okay, read this question carefully. The pattern of the magnetic field produced inside a current carrying solenoid will be what? A, B, C or D? Which is the correct pattern for solenoid? Which is the correct pattern of solenoid, of the magnetic field? But remember, they are asking inside. Very important point. Inside a solenoid. Ramesh ji is saying C. Rohan is saying A. Abhinav is saying A. Sensi is saying A. Abhinav is saying A. Okay. A. Very good. I know. Let's see. Inside the solenoid, let us just make the magnetic field lines of a solenoid. It is like a bar magnet. And we know inside the solenoid, the magnetic field lines are uniform and are kind of straight lines. So which is the correct pattern? A is the correct pattern. Very good. A is the correct pattern. Very good. Okay, next we have electromagnet. Now I have a solenoid. If I insert a soft iron core inside the solenoid, then that soft iron will become an electromagnet, right? A strong magnetic field produced inside a solenoid can be used to magnetize the piece of magnetic material like soft iron when placed inside the coil. The magnet so formed is called electromagnet. Done? Any doubt in this? Okay. A man-made magnet. Very good, Abhinav. Yes. Hi Krishna Kuti. How are you? Okay, next we have a question again. Give me the answer of this question fast. A soft iron bar is introduced inside the current carrying solenoid. The magnetic field inside the solenoid will be what? A soft iron bar is introduced inside the current carrying solenoid. We have a current carrying solenoid and inside we introduced a soft iron bar. Now the magnetic field inside the solenoid will increase, decrease, remains the same or becomes zero. Let me know. Let me know. A strong magnetic field produced inside a solenoid can be used to magnetize. Very good, very good. Prakash Yadav. Yes, that is exactly what a solenoid is. C. Abhinav is saying C. Okay, it remains same, you are saying. Then you are saying B. Okay, B. Okay, B. Mishra G is also saying B. Abhinav G is also saying B. Okay, great. Yes, B is correct. It will increase. Soft iron is a magnet. It becomes a magnet, right? It becomes a magnet, and when it becomes a magnet, the overall strength of the magnetic field increases. Okay, it will increase. So Nita Singh is also saying B. Krishna Kitty B. Very good, very good. Kaisar Mir also B. Yes, very good, Kaisar Mir. Okay, very good. Next question we have, show the polarity acquired by each face of the solenoid. This is a solenoid. Look at the battery very carefully. Now tell me, will A be a north pole or south pole, and similarly will B be a north pole or a south pole? Vlogs is back. Welcome back, vlog. Let me know which face of the solenoid will acquire which polarity. Oof. Let me know quickly, everyone. A will be a north pole or south pole, or B will be a north pole or south pole. My age is 83. Is time travel possible? Till now, no. Time travel is not possible. It is not. They say in physics that it is not a restriction of physics, it is restriction of our infrastructure. A is north, Abhinav is saying. B is south. Rohan is saying A is north, B is south, A is north. Okay, leave it. 80 is your age. Yes, 80 is my age. And B is south. Very good. Okay, so how did we decipher this? The negative part of the battery from N, that part will be north. So A is north pole and B will be south pole. Everyone remember how we crammed this? Remember this? Negative, the negative, N of negative will be the north pole, right? Done? Oops. Yes. Second, draw the magnetic field lines of force inside the coil and also show their direction. Is it okay now? I have drawn it multiple times. This will be negative, so this is N, and this is south, outside north to south, inside south to north. Same, north to south, outside south, inside south to north. Done, everyone? If current in a circular loop is in anti-clockwise direction, then it behaves like a north pole. If current in yes, then it behaves like a south pole. Very good, very good. Okay. Prakash also said north and B is south. Very good. North to south outside and inside south to north. Yeah, I read that also, Tony Stark. But it has to be something, the time, concept of time. It needs to be something. The class will be for 20-25 minutes more. We'll complete this chapter. That's it. Okay? Okay. Next we have. Oh, oops. Yes. Draw a pattern of magnetic field lines of a current carrying solenoid and a bar magnet. Again, yes, Sona, I remember. Ma'am, is there any numericals on the chapter? Let me see. I have some questions. The numerical won't be proper numerical, but it will be a mix of numerical and conceptual questions based on Fleming left-hand rule, which we'll study in just few minutes. Okay? Now, a bar magnet. This is a bar magnet. Done. North pole, south pole. The magnetic field lines will be something like this. It will be something like this. And it is similar, north to south, north to south, north to south, north to south, inside south to north. Similarly, for solenoid, it will be same. This is north pole, this is south pole. Just remember where the north and south pole is. North to south outside, south to north inside. Done? First part, done. Second, list one distinguished feature between these two fields. Tell me one feature that is a difference between the magnetic field of a bar magnet and magnetic field of a solenoid. Okay. Ma'am, what do you think? He's a great sir. He's a great teacher. I admire him a lot. Okay, let me know one distinguished feature between the magnetic field of a bar magnet or the magnetic field of a solenoid. They can't intersect each other, okay? That is a general property of magnetic field. What is the difference between magnetic field of a bar magnet and that of a solenoid? In constant magnetic field. Yes, I understood what you're trying to say. What happens is, see, bar magnet is a permanent magnet, right? So, magnetic field will be also permanent, but its polarity won't change. Its polarity will not change. Done? But in case of solenoid, if I switch the polarity of the battery, if there is, now this is the polarity of the battery. So this is negative, this will be north pole. So the magnetic field direction will be changed. So polarity of magnetic field can be changed. Done? Okay. Moving on to the next, we have has fixed north and south poles. Very good, Rohan. Correct. Okay. Next, we have the difference between permanent magnet and electromagnet. Permanent magnet is a permanent magnet. It is a temporary magnet. If we switch off the battery, the magnetism of the electromagnet will be lost. But in solenoid, polarity can change. Yes, correct, Abhinav. Then permanent magnet has fixed strength, it has variable strength. As if I increase the current in the solenoid, the magnetic field strength will increase, right? And third, it has fixed polarity, it has variable polarity that we just saw. Polarity we can also change by changing the direction of the poles. Yes, direction of poles will be changed by using the polarity of battery, Atif, right? You will change the direction of poles. How will you change the direction of poles? With the help of battery. Okay? Okay. Then we have next is, what is the difference between a bar magnet and an electromagnet? Let's just study it very quickly. Okay, bar magnet is a permanent magnet. You can take a screenshot if you want. It is a very important question. Bar magnet is a permanent magnet. It is a temporary magnet. Electromagnet is a temporary magnet. Okay, then we have, it does not require electricity to produce magnetism. Electromagnetic magnet definitely requires electricity, right? Then its magnetic strength is fixed and cannot be changed. Its magnetic strength can be changed. We just studied. It cannot be switched on or off. If we switched off the solenoid, temporary magnet will not be a magnet anymore, right? So it can be switched off. Made of hard magnetic materials like steel. Remember this, bar magnet can be made of steel, but soft iron is made up of, electromagnet is made up of soft iron core with a current carrying coil. Next, used in compass, fridge magnets, toys. This is used in electric bells, relays, cranes, motors, etc. Okay? Done. Permanent and temporary. Yes, Krishna Kutti. Very good. Okay, next we have force on a current carrying conductor in a magnetic field. Now it is a very important topic. Let's just study this, what Andre Merriam-Pierre said. They said a current carrying conductor experiences a force whenever it is kept in an external magnetic field. I have a current carrying conductor. When it is placed in an external magnetic field, when it is placed in an external magnetic field, it will experience a force, right? How can we cut magnet? Vertically, or that is not something precise. You can cut the magnet any way you want. Okay. Most important topic. Yes, it is most important topic. Okay, done. This is whenever a current carrying conductor is placed in a magnetic field, it experiences a force. Now, the direction of this force can be reversed when the direction of current through the conductor or magnetic field is reversed. Understood? The direction of force can be changed when the direction of current through the conductor or the magnetic field is reversed. Example, electric motor, electric generator, loudspeaker or microphones. Next we have Fleming left hand rule. Very important. That is, I don't know, focus on studying. Okay, so we have a left hand, Fleming left hand rule. Now, what does Fleming left hand rule says? It says, when you point your index finger in the direction of magnetic field and your middle finger in the direction of current, then thumb will give the direction of magnetic field, direction of magnetic force. Then thumb will give the direction of force that is acting on that current carrying conductor when it is placed inside an external magnetic field. Done. Okay, done. Next we have is what? We have a question. Okay, everyone, back to here. What will be the answer of this question? The force experienced by a current carrying conductor placed in a magnetic field is the largest. The force is largest when the angle between conductor and the magnetic field is what? Understand, before that there is a very important formula, QV cross B or QVB sin theta. Now tell me when the force will be largest for the angle between conductor and the magnetic field, the angle between V and B. What should be the angle between V and B so that the force on a conductor should be largest? Arey, C. Abhinav is saying C. Okay, iPhone, do that. Okay, C. See, that is 90 degrees. Great. Everyone is correct. Let me just quickly explain you. Why? Because according to this formula, this will be maximum. Force will be maximum when theta is maximum. When sine theta is maximum. And sine theta is maximum for which angle? It is maximum for 90 degrees angle. Very good. Very good. C. iPhone is saying C. Ramesh, Solenoid. Very good. Very good. This one I didn't study. Which one, Rohan? It's not D, it is C. Okay? Yes, the direction of force which act on a current carrying conductor placed in a magnetic field is given by Fleming left hand rule. Very great. Very good. Hanji Neera Kuku. Okay. Next, we have one more question. State the rule used to find the force acting on a current carrying conductor placed in a magnetic field. Given below are three diagrams showing entry of an electron in a magnetic field. Identify the case in which the force will be maximum and minimum. There is an electron going upwards here at an angle, here in the direction of magnetic field. In which case the force will be maximum and minimum. QVB sine theta. These are the only kinds of numericals that you will get in this question, okay, in this chapter. Explain again. I'll explain in this question. It is the same question, okay? Arey, into the page. Yes, listen to me. But they're asking in which case the force will be maximum. We don't need to know the direction of force here. Okay? Third case, third. Solo edits is saying third. Ramesh is saying okay. Okay, yes. Let's see. See, in this the angle between electron and magnetic field is what? 90 degrees, right? In here random angle, and in here the angle is 0 degrees, right? So we have two angles, 0 degree and 90 degrees. So sine 0 is what? Sine 0 is 0. So force will be 0 for 0 degrees. So in third case the force will be 0. And for 90, sine 90 is 1. That is maximum. So force will be maximum for angle 90. That is the first case. So the force will be maximum. So force is maximum for first case and it is minimum for third case. Done? Understood? Okay. Yes, alpha particle is positive. Yes, Uma Devi. Okay, done. Next, let's move on. We have another question. What is meant by magnetic force? See, this is also a previous year question or the most repeated question, and we have to directly tell what is a magnetic force. They might explain the rule to determine the direction of force. Rule to determine the direction of force. Let me know the answer. Okay, force, let's see. Magnetic force is the force experienced by an electric charge or a current carrying conductor or a magnetic material when it is placed in a magnetic field. Done? Till here it is done. Now let me know which is the rule that is used to determine the direction of force experienced by a current carrying conductor placed in a magnetic field. How does this force, first tell me which is the rule. Fleming, yes, Fleming. Uma Devi is saying. Seema Yadav, hello, I am back with another idea. I am Sona. Okay, you are Sona. Okay. Okay, yes, Fleming, left hand rule. Very good, very good. So the force, the rule that is used to determine the direction of force is Fleming's left hand rule. Fleming's left hand rule. Very good. Now we need to answer some questions. What will happen if I double the magnitude of current? What will happen to the force if I double the magnitude of current? See, we have two formulas, F equals to QVB sine theta, but along with that one more formula that you can remember for some extra marks, ILB sine theta, where I is current, L is length of the current conductor, and everything is same. Okay? What will happen if I double the magnitude of current? If I double the magnitude of current, the force will also get doubled. The magnitude of force will also get doubled. Then force double. Very good. Abhinav, Atif, very good, very good. Next, we have reversing the direction of current flow. What will happen to force if we reverse the direction of current? Yes, force double. Yes, it is in the syllabus. Solo edits. Yes, exactly, Ramesh. Good. Ma'am did not understand. What did you not understand, Uma Devi? You can just comment once. I'll read your comment. Okay. Okay. Duration थक गया. या कौन थक गया? Yes, Uma, please don't spam. Yes, the direction of force will reverse. Very good. Rohan and Abhinav. Okay, great. The direction of force will also reverse. Very good. Then reversing the direction of magnetic field. Again, I'll just tell you, this also reverses the direction of force. Okay, these are the three answers to these questions. Done? Okay. Next we have, here we have different kinds of wires. Who was asking? Someone was asking different kinds of wire. Next live of physics, it will be let me tell you, you can go join the WhatsApp channel. There is a link down in the description. You can go and check the schedule. Okay. Okay. So this is, we have three kinds of wires. Let's do very quickly. First is red wire, that is live wire. Second is black wire. Third is green wire. Live wire carries the electric current from the powerhouse, from the electric pole to your home. Neutral wire or black wire takes back the excessive current that came into your home, uses the current, takes back excessive wire back to the pole. Green wire, earth wire, what it does is, first subject question, which question, Uma Devi? Earth wire, what earth wire does is, it connects, see, you have metallic appliances in your houses, just like we had coolers in our back days. Okay, not the plastic ones, the metallic coolers. So what it happens is, the charge resides on that surface. So if I touch it, I get shocked. So what they do is, they collect, the earth wire collects all the excessive charge from the area, the surface of that metallic conductor, and passes it down back to the earth. Okay, that is why it is called earth wire. Done? Okay. Next we have AC and DC. AC looks like this, you can see it. DC looks like this, right? AC is alternative, it increases and then decreases. AC, it remains continuous. Alternating current, it changes its direction periodically. It is going up then coming down, right? So it is changing its direction periodically, but it has fixed direction. Then it has changes its magnitude. It increases the magnitude, decreases, then negative, then 0. So magnitude is continuously changing. Its magnitude is fixed. It is used in battery and cells. It is used in our household circuit. AC has less power loss over long transmission. DC has more power loss over long transmission. Biology, you'll have to wait, I think, a little bit. Okay. Earth wire is used for safety measure. Yes, earth wire is used for safety measures. Uma Devi ji, please don't spam. Okay. Next, we have this question. Go about this question and let me know the answer. An electron enters a magnetic field at right angles to it as shown. The direction of force acting on the electron will be what? The direction of force acting on the electron will be what? To the right, to the left, out of the page, into the page. Electron is coming downwards and this is the magnetic field. They are making an angle 90 degree because they have written it, right angles to it. Okay. Okay, guys, just ignore it. You let me know the answer to this question, okay? Into the page. D, into the page. D. Okay, into the page. Ramesh is also saying D. Okay, we will be using which rule? Let me know we will be using which rule? We will be using Fleming left hand rule, right? We'll take our left hand. Now, index finger is in the direction of magnetic field. So that is this. And current, remember, electron current is in the opposite direction of electron. So current is in upward direction. So magnetic field, current is in upward direction. Thumb is into the page, that is correct. Thumb is into the page. D is the correct answer. Okay, great. Okay. Let's move on to the next. We have short circuit and overloading, a very, very important concept. They can directly ask you in the question what is short circuit, what is overloading. Okay. Hi, namaste Sandhya. How are you? Okay. Short circuit happens when neutral wire comes in direct contact with the live wire and excessive current passes through it, and that is what we call short circuit. Okay. Fleming left hand rule, the use of Fleming left hand rule. See, Fleming left hand rule is you have placed a conductor in a magnetic field. Now you want to know where the force is acting. So that is what Fleming left hand rule is used for. Okay. Hi Aman, how are you? Okay. Shortening of circuit. Yes, Solenoid. It's very good. Yes, class is almost about to end. Okay, done. Short circuit. Overloading. You have seen those multi-pin plugs. I have it right here, but I can't unplug it. The light will go off. But short multi-pin plug is something in which you can connect different appliances in one single plug. Right? So what happens when you connect so many appliances in one single plug, in one single circuit, it will draw more current than the safe limit of the circuit, and then the overloading will happen. Right? Fleming right hand rule. What are you asking? Fleming right hand rule is not in your syllabus, beta. Okay, so do not, at this point we will not be doing any other topics. Okay. Yes, we are almost, the class is almost over. If a live wire and neutral wire comes in contact and either directly or via conducting wire, then it's called short circuit. Yes, very good. Wires overheat. Yes, in overloading, lots of current, they will demand lots of current than its safe limit, so that can lead to even fires. In case of the resistance of current is almost zero, which results in a flow of large current, this heats up the wire dangerously and may lead to fire. Yes, very good. Yes, call me grandma. Bro, talking in English. Okay. Yes. Okay. Next, we have a very important difference between overloading and short circuiting. Look at it very carefully. It occurs when too many electrical appliances are connected to a single circuit and draw more current than the wire can safely carry. That's what we studied. Short circuiting, it occurs when live wire and neutral wire comes in direct contact due to damage or insulation failure. The total resistance of the circuit becomes low. In overloading, what happens? Lots of appliances are there and they are connected in parallel. So, total resistance becomes low because many appliances work together, increasing the current. The resistance becomes almost zero in short circuit and causing a sudden surge of current. Then it causes overheating of wires, may lead to melting of insulation. It produces a very large current suddenly, which can spark fire and gets damage to our devices. It usually happens when high power devices, heater, iron are used together in one socket. It usually happens due to broken wires, loose connections or damages. It is an important point. Short circuit happens due to damage of insulation, loosening of wires. It happens when we connect lots of appliances in one socket. Okay, current increases gradually, current increases instantly and violently in short circuit. Okay, okay grandma, okay. Everyone knows this. This is a household circuit. Okay, everyone knows this circuit, right? Yes, MCB is used and this is our MCB. Right. We have three wires coming into our houses: neutral wire, live wire, earth wire. Earth wire is of green color, live wire is of red color, neutral wire is of black color. Here I couldn't show colors. Okay, this is your board, your electricity board fuse, and this is my electricity meter, where we can see what is the current that we are using. Okay, now this is fuse. Fuse is connected in series with a circuit, we know, to protect our appliances, and you can clearly see it is connected in series, right? Now this is the distribution box, which we called MCB as well. Okay, now this distributes the wire among different plugs. So this is plug number 1. Can you see? This is a live wire. This is a live wire. It is of red color, goes into each plug. Then this is a black wire, neutral wire, and this is my earth wire, everyone. Okay, which goes into each plug, right? So this is live wire, black wire, earth wire. Then parallel circuit is used. How? In which? Where? Okay. Done. This is done. Next we have, we are done with our everything. Okay, we are done for this live session, everyone. We are done for this live session. We did all the chapter electricity, whole chapter of magnetic effects of electric current with so many PYQs and questions. What is the meaning of earthing? Earthing is used to do, earthing is the passing of all the excessive charge on the metal body into the earth. That is why it's called earthing, to protect from leaked charges or us getting shocked. Okay, The live wire, yes, the live wire gets the potential 220 volt, and in our houses we get the frequency because we get AC. So the frequency of the AC source is 50 hertz. Very good, Seema. Okay. Neutral wire, zero potential. Very good, very good. Okay. Everyone, we are done for this live session. Thank you everyone, Mikasa, Rohan, everyone. I hope you understood all these two chapters. In the next live, we'll do other two chapters, that is light and human eye, because it is better. Yes, yes, Uma Devi, very good. Okay, done. Okay, thank you, Rohan. That is it for this class. We'll meet you in the next one. Keep studying, keep working hard. Your boards are very near, less than 15 days. So, be very careful, study hard and do wonders. Okay? Thank you, Tanmay. Bye. Okay, bye. Okay.